So good afternoon to one and all present here. I welcome you all for the final day ATAL online FDP on the topic Technological Advancement in Manufacturing and Industry 4.0. On this momentous occasion, I would like to welcome today's first session resource person, Dr. M. Arulprakasajothi, Professor, Department of Mechanical Engineering, KCG College of Technology, Chennai. He has published 23 research papers in SCA journals and 31 research papers in Scopus Index journals. He got the fund of nearly 1 crores from various organizations. He has guided a 3 PhD scholars at VIT Vellore. Despite being his busy schedule, he has given considered for our FDP. Once again, I welcome you, sir. I will hand over the session to our resource person, Dr. Arulprakasajothi, sir. Sir?
Yes, sir. Am I audible now?
Yes, sir. Shall we start, sir?
I will share my slide.
Okay.
Is this visible to you? Screen?
Yes, sir. Visible, sir.
Is this full screen or?
Yes, sir. Visible, sir.
No,
visible,
sir.
Sir, not
is this full
screen,
screen?
sir. Not in full screen, sir.
Check it now. Full screen or plus? Sir, please check. Anyone, please help me.
Sir, screen is not visible, sir.
No, sir. Is this full screen or?
No, brother. No, brother. Screen not shared actually.
Added.
I will check it once again.
Okay.
Is this okay now?
Yes, sir.
Is it in full screen or not?
So it's in full screen, sir.
Okay, sir. Sir, is it moving? Slide?
Yes, sir. Move. Yes, sir. Slides are moved.
Yes, sir. A very good afternoon, one and all present here. This is a great opportunity for me. First of all, I want to thank Department of Mechanical Engineering, JCTCET College of Engineering and Technology for this wonderful opportunity. Anyway, I want to share few thoughts related to energy materials for thermal management system. Anything interrupted in between? If you have any questions, please ask me or stop me. Then it is very beneficial to discuss few things for clear understanding. Is this okay? Anyone please respond to me in between. Sometimes my network maybe go wrong. Otherwise, sorry, there is a problem in sharing screen. With these, please, anyone please help me. Anybody is there, please tell your name. I will call you in between and check whether everything is okay or not.
Okay, sir, I will inform you, sir.
Yeah, I will. Right. First of all, I want to, in this presentation, I want to discuss about the thermal management, the importance of thermal management, and the application of thermal management in electronics, electrical vehicle, renewable energy systems. Then the materials aspect, importance of materials and heat control. First of all, I want to emphasize what is the importance of thermal management for mechanical engineers, because as we know, the core branches like civil, electrical, mechanical gets deteriorated for the past 4 or 5 years. Right? People are thinking that there is no scope for mechanical engineers, but it is not true. If you know the fundamentals of heat transfer and material science and manufacturing, you are the future pillar of India. Not only India, for any global technology, because we need to emphasize this with students. If they know the basics of heat transfer and thermodynamics and energy systems, materials and manufacturing, if they know these five subjects, it's very easy to get some placement in the important companies. Then there is a bright future for a faculty to attract more fund. This is what I want to share, because the thermal management means it's simply talking about conduction, convection, radiation and combined heat transfer effect. I hope many faculties are here, they know the difference between thermodynamics, heat transfer and the basic equations, mathematical equations behind conduction, convection, radiation, everything. I don't want to discuss in detail in this talk, but this is a basics for thermal management. Because why? The thermal management means we are going to discuss about heat generation, thermal runaway, material degradation at high temperature, then energy efficiency with considering sustainability concerns. Heat generation means even when we walk, automatically our body generates heat. This is the basic principle behind the movement. Without movement, we can't do anything. Means without the application of heat transfer, nobody move, nobody work in the earth. So that not only in the earth, in the space also, we need to consider the heat transfer. We need to control the heat transfer with respect to the operating temperature of any devices. Right? This is the issues and the solution for electronic items and battery. Whenever any system exceeds the operating temperature, what happens? Automatically the degradation will happen in the micro level to the macro level. So micro level, the cell failure will happen, that leads to the explosion, that is called thermal runaway in the battery system. The same way happens in the PCB board or any kind of electronic circuit. Whenever the operating temperature increases, automatically the heat transfer leads to the spoil of any system. So these are all these are all the advantages. Current technology provides some kind of solution to control the heat transfer, because whenever the system operates, the heat transfer accumulates at some point. We can call it as hotspot. Identifying hotspot, removing hotspot, controlling hotspot. This is very, very critical. Even Intel, they spend lots of money in this research. Anybody from this participant, if you want to do any kind of research related to thermal management system, directly go to the Intel website and find the possibility of getting fund from them, because they are ready to fund to do these kind of innovative heat sink applications and heat sink, particularly heat sink with nanomaterial. They are interested in this area. So any electronic equipment, from the semiconductor to the LED, then here electric battery vehicle, wherever you go, the controlling the temperature controlling the uniform temperature, the uniform distribution of heat. This is a critical issue. Whenever, because as the mobile system, the technology increases. What is the prime problem in the mobile? The prime problem in the mobile is heating. Whenever you use that mobile beyond certain limit, automatically it is heated. Means internal heat generation happens. The same way the battery system. Every 2 years we need to change the mobile phone. Why? Because the technology behind it, particularly the battery technology behind it. That every 2-3 years they are changing the charger also. We need to spend mobile as well as charger as well as battery, because now nobody is using the old charger. People are using C-type charger now, right? For that, the cost behind that. Everything depends upon the heat transfer engineer, right? So this very, very important to consider some 6 steps while choosing the right thermal management solution. The first one is the requirement. What is the requirement? For that, we need to focus on heat source, load, and the operating temperature. Then the understanding of environmental condition. Chennai means the environmental condition is different in the hills region, right? Some people are working in the IIT Mandi. So there is, whenever we need to do the experimental setup, we need to consider the environmental situation. There is the average temperature for IIT Mandi people is 20 degree, but Chennai it is 28. So that atmospheric condition is also very important. The second step is evaluating thermal management option, whether passive cooling or active cooling or the combination of both or advanced cooling. This we need to consider. Then the third step is considering material properties, because as a mechanical engineer, mechanical faculty, the thermal conductivity is the prime property of any devices, because the thermal conductivity decides the heat transfer efficiency. For copper, the thermal conductivity is nearly about 400, but all the other metals, it has very less thermal conductivity compared to copper. But the carbon nanotube and graphene, the thermal conductivity is 3000. It's a powder, but it has more than the value, nearly 10 times. Every year, the report on thermal conductivity of graphene and CNT is increasing. Means we need to study more about the nanomaterials. When you add copper with some nanomaterial, the same thing copper, when we talk about the material, the copper and aluminum. The aluminum has less weight than copper, but the thermal conductivity, it's no way it is comparable. Copper is very high compared to aluminum. But when you coat graphene or CNT with aluminum, with the same weight, we can achieve some kind of heat transfer efficiency through aluminum. So combination of aluminum plus nanomaterial leads the copper performance. This is what the research community reported as of now. Then the integrating solution device design. Apart from thermal conductivity, electrical insulation and durability, then we need to consider the space constraint, weight consideration, compatibility with other component. Whenever we are talking about thermal management solution, we need to consider whether we need to select passive or active, or we need to go with the higher thermal conductivity material, or we need to consider the weight or the space constraints. Other than that, these two are very important, the balancing cost and performance. The budget, cost-effective solutions. Whenever we give solution to the battery thermal management system or electronic thermal management system or space thermal management system, we need to stick with the budget, the cost-effectiveness, because that TRL level depends on the budget, the cost estimation. That the implementation part. Anything happen? Anyone asked anything?
No, sir. Someone they
Unmuted,
they
right?
unmuted.
Okay. Then the last step is testing and validation. In the previous 5 steps, you just think about first step, Who is the lead in this first step? Thermal engineer, mechanical engineer. Who is the second lead in the second step? Cooling. We need to talk about cooling. Mechanical engineer, purely mechanical engineer here. Then material properties means mechanical engineer means it's inclusive of material and other aspects. Solution provider. Here some other person will come in the fourth step, the space and weight. Then the 4, 5, the balancing, budget, cost estimation, some other people will come. The testing and validation, here the thermal cycling, real world simulation, reliability and efficiency. These 6 steps are very important when we are considering about thermal management solution. You see, this is the application of thermal management. You can take any one. First one is electrical and electronic. Second one is space, right? This is electrical and electronic. This is space, satellite system, renewable energy, any form of renewable energy, either solar or wind or whatever it is, power plant. Everything. This one, anyone guess what it is? The application? Anyone from the participant, please guess what it is? The fourth one, nobody. It's a medical equipment, because in a MRI scan or wherever, whatever the medical equipment, in that also we need to consider the cooling mechanism. Then this is battery, this is industry, this is data center, this is IC engine. These are all the prime thing people are working on, reducing the size of any system in this industry, particularly wherever you go, the Tesla. Design consideration is very important. Whenever you need to focus on design, you need to focus on the cooling mechanism, refrigerator or heating mechanism from the moving parts, right? So that the entire design, the compactness depends upon the heat transfer. Whenever you want to make a compact mobile phone, you need to take care of the heat accumulation of the mobile phone. You need to take care of the charging time. Whenever you work on the charging time, you should know the basic understanding of heat transfer, the data centers. So nowadays, wealth depends on data. Based on your data, you will get a benefit out of it. So that the data center, industry process, wherever you go, renewable energy, medical equipment, there is an opportunity, there is a potential opportunity for thermal engineers, particularly those who know thermal management system. This will give you many research topics are there in this slide. Because how to select the application, the operating temperature. So the electronics means 0 to 85 degree. Developing an experimental setup to work on room temperature to 85 degree is very easy. So whatever the application, whatever the research, whatever the experimental setup related to electronics, it's very easy. Because it's whenever you talk about academic work, nowadays people are talking about the paper and publication, right? So encourage the third year student to work on any one of these area to develop a small experimental setup. That is enough. Automatically, when they develop the experimental setup in the third year, definitely in their final year project, they will give enough result, some report to you that is enough to produce 2-3 papers. Because electronic cooling, electrical vehicle cooling, aerospace cooling, you can call anything. Only the industrial process, the temperature is different. The aerospace, the temperature is different. You can see all the others. The temperature is nearly 100. The average temperature is 100. So if you develop an experimental setup working in the range of 60 to 100, this is enough for all the application. So the solution is heat sink or liquid cooling or PCM or heat pipe or passive cooling, heat exchanger, whatever it is. I will help you. The coordinator will share my email ID to you. Otherwise, through online platform or in LinkedIn and other Google platform. You can directly mail me. I will help you to develop a experimental setup with the cost of around 5,000 to 6,000. That's enough. Only thing we need to get the help from the EEE or AI students to operate the Arduino board to store the temperature profile data in the laptop in the form of Excel sheet. For that, you need to collaborate with other faculty. Identify one faculty from EEE or EC or AADS. They will help you to write the program to store the data, the temperature profile in the form of Excel sheet. That cost previously, the data logger is required. The data logger cost is nearly 1 lakh to 2 lakhs. So as a private engineering college, they don't provide this kind of facility to keep data logger in our laboratory. But nowadays that Arduino board, it costs only 2,000. It comes along with the temperature sensor. So the temperature sensor, even one temperature sensor is enough. So that cost is 2,000. That heater cost is 100. Then the heat exchanger cost is 5,000. Maximum the experimental setup cost is 8,000. So with 8,000, you can construct an experimental setup for thermal management system. You can study n number of result is possible, n number of publication is possible in this area. See this is the type of thermal management system. One is active management, another one is passive management. As a faculty, you know the difference between passive and active. Passive means without any fan, the natural radiation, natural evaporation, or natural wind is enough to extract heat or to make efficient heat transfer. But in the case of active, some kind of power consumption is inevitable. The fan or some other moving parts is essential to make active cooling. See this. By definition, passive means it's rely on natural heat transfer mechanism without external energy input. Active cooling uses external energy. Right? So heat transfer mechanism, conduction, natural conduction and radiation in passive cooling. In the active cooling, forced convection. There is no energy consumption in the passive cooling, but in the active cooling requires some continuous energy input. Complexity is no moving part in the passive cooling, but there is number of moving parts in the active cooling. This is the difference, active passive. Right, this is the heat sink that really some LED light, some people are using heat sink. This heat sink, this cost, you can check it in the Amazon. This cost is 100 rupees. You can buy this from the Amazon. No need to depend on any fabricator to make this kind of heat sink. It's readily available. Not only aluminum, any material. You can order it. You can check it through Amazon profile. So this is some kind of aluminum. This is copper. This is the heat pipe. You can see the pipe here. So some heat pipe means there is a flow of fluid, some little complicated than heat sink. So people, those who want to make a heat pipe based experimental setup, we need some kind of external support like IIT or Anna University. You need to depend on some research people from the reputed institute to develop this kind of experimental setup. Otherwise, it is also possible with the UG level project. So this is the thermal management options: the heat sinks, heat pipes, the liquid cooling, PCM, fans, nanomaterial. These are all the words related to thermal management system. You should know these things. What is heat sink? This is heat sink. Whatever we shown, right? This is aluminum heat sink. This is copper heat sink. So what is heat pipe? Heat pipe means there is the pipe side. There is a pipe. It provides the passage to flow fluid in it. Right? So liquid cooling means nanofluid. We can use nanofluid in it. PCM, phase change material. We will talk about what is phase change material, the thermoelectric coolers, then fans for active cooling, nanomaterials. See, this is the material related to this. Many materials are there. In this, the phase change material means its cost is very, very low. The paraffin wax, half kg of paraffin wax is 500. You can Google it. Definitely, wherever you go in Coimbatore area, it's very easy to get the paraffin wax in the container. So half kg container is enough, because based on the heat sink passage, heat sink volume, we need to fill the PCM. Right? So the liquid form is half kg means half liter means we can design the heat sink accordingly. Right? So all the other thing except PCM, you don't worry about these things: thermoelectric materials, thermal interface materials, and nanomaterials. This combination of PCM nanomaterials, the chances of getting accepted, I'm talking about from the point of from the perspective of paper and research funding. So PCM with nanomaterial, that chance, there is a high chance of accepting your paper. This is about phase change material. First of all, there is different type of phase change materials are there with different melting point, with different melting and solidification point. It classified into organic, inorganic, eutectic types, each with unique thermal properties suited for different energy storage applications. So application means energy storage, particularly for energy storage, the temperature regulation in buildings and enhancing the efficiency of renewable energy system. What is the advantages? It is latent heat, because latent heat energy is very high in the case of PCM. Right? So improved thermal management. Whenever you want to increase, whenever you want to transfer more amount of heat, there people are using PCMs. So energy saving and environmental sustainability is possible. See this. The basic mechanism behind PCM, it's very simple. Basic example for PCM is water. Right? It has three forms: solid, liquid, vapor. So solid means we can call it as ice, liquid means water, then vapor means it's steam. The same way, PCM means paraffin wax. There is change in solid form to liquid form to solid form is possible. So this is one cycle. When you heat, when you give the rise in temperature, the solid form of PCM melts. So this is PCM melting. So whenever that melting process, the temperature remains constant, because as a faculty, you know what is latent heat, what is specific heat, right? The amount of heat required to convert solid into liquid means it is latent heat, right? So the complete melting process, the 100% melting, when it reaches the 100% melting process, then there is a further increase in temperature takes place. That is called superheated region, right? The same way, during the heating process, solid form of phase change material converts its solid form into liquid form. Then the same way, whenever you reduce the temperature, it converts the liquid form of temperature, liquid form of position phase to the solid form. This cycle happens due to the addition and removal of heat. The same way, whenever the solid to liquid phase change happens, it's a kind of energy storage. So it holds some energy during the phase transition. So the same way, it releases the stored energy in the discharging time. So the charging time means it's holding energy, storing energy. Discharging time means it releases energy, right? So we can use whenever the excess, for example, in the daytime, there is a high amount of solar energy is possible. So whenever there is solar energy, PCM converts its solid form into liquid form, right? It stores energy. Evening time, when there is no solar energy, at that time the stored energy is released. Means the absence of sun influence the discharging. Liquid to solid process will take place. So solid to liquid process takes place when there is sun, when there is excess energy. Then Liquid to solid process happens when there is no sun. That is discharging energy. Charging means we store. Discharging means we can use the stored energy when there is no sun. This is the use of phase change. Organic means paraffin. Inorganic means salt hydrates. Eutectic. This is the classification of phase change materials already we discussed. So this study reported by some researchers in applied thermal engineering, because applied thermal engineering, as a mechanical engineer, if you publish at least one paper in the applied thermal engineering, it's a huge respect for a thermal engineering, particularly for a mechanical engineering faculty, right? So here you see, this is heat sink, this is electronic devices. Electronic device dissipates heat to the heat sink. Here the medium is air. So due to the circulation of air, flow of air, the extraction of heat will increases. Otherwise, in another word, we can say the extraction of heat depends on the circulation and flow of air in between the heat sink, right? Then the B, they filled some PCM here below the heat sink. They kept PCM in the container, right? What happened? They automatically, before transferring heat to the heat sink, the PCM absorbs some huge amount of heat. What happened? The operating time increases compared to A and B. The operating time increases in this case because of the presence of PCM. Here they filled the PCM in between the fins. The same way, compared to A and C, the energy absorption, or in another word, the heat transfer increases, right? Here it's a combination of PCM and air. Because why I shared this image, because with only one heat sink, it's cost around 500. They studied nearly 6 different experiments. They did different experiments. Initially they studied without any PCM, only air present inside the fins. Then they filled PCM between the electronic device and heat sink. Then they filled the PCM inside the fin. Then they kept some emptiness, some air between the PCM, right? Then see the porous media. The porous media means it's a porous structure. So they inserted the porous structure in between the electronic device and heat sink. Then they studied, they reported the performance of heat sink in the highly reputed journal, right? This is the setup. We need to give the heat here. This is the heater, right? Some kind of insulation is there. Inside, you can use any wood. That is enough. Because our operating temperature is nearly 100 degrees centigrade. For 100 degrees centigrade, you don't search different insulation material. Simply use wood as your insulation material, keep the heater. Then this is the heat sink. This is the gasket. Inside, they filled the PCM. This is the sheet. What is the purpose of this sheet? You can use any acrylic sheet to avoid leakage, or the convection with the environment to avoid convection with the environment. So only 2 things is required. How to control this heat input? For that you required some power controller, watt controller. How to measure the temperature change? For that you need a sensor and temperature monitor. So power controller, temperature monitor, this is enough. This is the experimental setup. See how many heat sinks are there. It's a circular fin, triangular fin, I-shaped, square shape, cross shape. So you can do many literature, many different types are available. Otherwise, you share this diagram to your student. definitely they will come up with different thing. Right? So, one second. Am I audible now?
Yes, sir.
Am I
Audible.
audible?
Audible, sir.
மேம் நான் ஒரு மீட்டிங்ல இருக்கேன். நான் ஒரு 1/2 hourல சொல்லிடுங்களா? Am I audible?
Yes, sir. Audible, sir.
Okay. So this is anyway we discussed about heat sink PCM. Why this is required? This is required for the thermal management solution, where it is applicable in the different areas, even in the medical equipment to the space satellite systems, aircraft system. Right? So we identified 8 different applications for thermal management system. The solution is active and passive. In this active passive, both is okay with this, okay for the study. Only thing is we need to consider the natural conversion for passive, forced convection for active. Right? So along with heat sink, PCM will give better performance. So that this is thermal conductivity, supercooling. What is the meaning of supercooling? This is very important, right? So for the cyclic process, whenever the water, consider water exactly melt, solidify at 0 degree, melt at 100 degree, evaporate at 100 degree, melt in between, right? But in the case of PCM paraffin wax, exactly at 50 degree, it converts its solid phase into liquid phase. It's a charging process. When discharging, that solidification happens at exactly at 50th degree in the first cycle. In the second cycle and third cycle, this temperature may vary. If the temperature varies, means at the center, the melting point is different from the wall. Wherever you give heat, at that point, it melts at exactly 50 point. But other places, the temperature changes, that solidification temperature changes. Some kind of colloidal form will be there inside the PCM. That is the PCM. The problem with the PCM, the volume change and leakage, along with this supercooling effect is very, very important. Then the thermal conductivity is very, very important. For that, the nanoparticle is important. If you add the nanoparticle, the efficiency of the system increases, PCM increases. See how to add the nanoparticle. This is the liquid PCM. First of all, we need to heat this PCM, then convert solid form of PCM into the liquid form. Then you drop some nanoparticles, right? Stirrer and sonification process make some uniform dispersion of nanoparticle into the liquid PCM. Then you just keep it in the atmosphere, automatically solidification takes place. Then this process leads to the inclusion of nanoparticle with the PCM. The same thing, nano PCM and paraffin. This is paraffin is liquid form. They dropped nanomix or graphene, any nanoparticle, they dropped. The sonication process for 3 hours at 70 degree used to make the uniform dispersion of mixture, right? To make the mixture uniformity, to control the uniformity, this sonification process will work. This is the sample, right? Then the same way, instead of adding means the entire thing become black. It's a shell encapsulation covering a surface, a boundary. So decorated the decorated paraffin wax with the nanoparticle. This is encapsulation. So this is also possible with higher level of facilities. you just work with any physics or chemistry people, definitely they will help you to synthesize new nanoparticle, or they will help you to make this kind of process. What are all the nanomaterials are available? It is graphene is available, nanotube is available, CNT is available, and copper oxide, aluminum oxide, titanium oxide, add nano one. Many companies are available. So definitely within a week you will get these kind of nanoparticle based on your requirement, right? So how to select this nanomaterial? Based on the thermal conductivity or heat transfer, based on the PCM, right? If the PCM have some leakage problem, we will go with CNT. What is the thermal conductivity? We will go with the graphene, right? So for supercooling issues, we go with the aluminum oxide. So based on the issue, based on the PCM, we select the nanomaterial. This is very important thing. Everybody guess what it is. This is the 3D printing facilities provided, particularly the metal 3D printing technology provided a very good opportunity for thermal engineers, particularly for heat transfer engineer, because very few studies are available in the research papers. The 3D printing people only used for polymer, particularly for medical application or some other application. Metal 3D printing, it's very less. Particularly metal 3D printing for heat transfer applications, it's very less. You can find hardly 2-3 papers in the reputed journals. So that there is a huge opportunity. It is very easy in Chennai, Tamil Nadu government, they developed a TANSOM facility, TANCO facility in the tidal park. You visit the tidal park, the GE facility, Siemens facility is available with less cost. The only thing is you need to talk to your your principal or your HOD. You simply visit that facility, GE facility and Siemens facility available in the tidal park. For that, you need to book an appointment. The prior appointment is required. Through online, you book the appointment with TANSOM people, right? Visit it and some kind of MOU, initiate some kind of MOU with these people, then it is very easy to use the facility there. Anybody from Tamil Nadu can use the opportunity for research purpose or learning purpose. Even they are providing some software training. Not only for 3D printing, we are many facilities are available there. Nobody knows about that facility. It's a very huge General Electric metal 3D printer is available in the tidal park. Only thing, with prior appointment, you need to visit the lab. Based on the slot, they will give you some service, right, with minimal cost, because it's a government subsidized facility. So that all make use of that. These are all the heat sink shapes printed using 3D printing, which is not possible through conventional process. See, there is plenty of designs are available. Only thing, share it with the student, do some literature, get some innovative, creative design, convert that into STL file, give it to the people, TANSOM people. They will tell what is the charge for that. Right? For research purpose, you can use this, because very few people reported heat transfer aspects of 3D printed heat sinks. Immediately your paper will accept if you work in this area. This is my recent work published in the Applied Thermal Engineering. It's a additive manufactured porous structure. Right? So I just explained what is our work. We designed a porous structure, right? Then we converted that design into a STL file. There is a facility available, Siemens facility available in the NIT Trichy. So through NIT professors, we contacted them, we printed this porous structure. This is the design, CAD design, this is the porous structure. Then we grown graphene using chemical vapor deposition method. This is very costly equipment available at IIT Mandi, right? So we grown graphene over the porous surface, right? You know, what are all the things is required? Argon, hydrogen, acetylene is required. When you allow argon, hydrogen, acetylene, then during the temperature was maintained at 1000 degrees centigrade. So when you allow these three gases in the enclosed chamber, when the chamber is maintained at 1000 degrees centigrade, automatically graphene will grow on the surface of 3D printed structures, right? See, this is the plain structure, this is the CNT grown structure. Some characterization studies we did to ensure the presence of CNT. This is the experimental setup. It consists of an enclosed acrylic box. Inside we provided a fan for the forced convection, right? Then there is a heater. This heater controlled by the auto transformer. What is the use of auto transformer? We need to control the heat input. We studied this experiment. We did the experiment with 3 different heat input: 5 watt, 10 watt, 15 watt. How to control this 5 watt heat input, 10 watt heat input, 15 watt heat input? For that, this auto transformer is required. Then this is the printed, 3D printed stainless steel porous. We kept the temperature sensors on top of it. It's a surface temperature. It's right. That temperature measured, the temperature values stored, captured by the MIDI logger. This cost is around 5 lakh, 2 lakhs. But some Arduino board is enough. 2000 rupees Arduino board do the same thing, right? Here 10 port is available. Means at the same time we connect 10 sensors in this MIDI logger, so that the cost is very high. But the Arduino board at a time you can insert only one. This is the experimental setup. The cost of the entire experimental setup is less than 10,000. This auto transformer, you can check it in the Amazon. It's 2000. This Arduino board 2000. Heater is 500. This fan is nearly 500. So 4,000-5,000 nearly the porous structure. It's 3D printed porous structure. The cost is different. But otherwise, the heat sink, that is 2000. That's all. So with this, then you can order some nanoparticle. That cost around 2000. That's all. The paraffin wax, 500 rupees. You can generate this kind of graph with anything. So we observed some delta, temperature difference, right? So we observed the effect of CNT. So we reported in the applied thermal engineering. This is also an interesting work. We developed 3D printed porous regenerator for Tata Institute for Fundamental Research, because they are using the same kind of regenerator for the liquefaction of nitrogen. You know, the nitrogen liquefaction takes place at 80 Kelvin, right? So for that, this is the prime component in the process, the regenerator. That regenerator, you know the difference between recuperator and regenerator. Regenerator is the interesting device. The same passage is provided for cooling medium and the heating medium, right? So when the heat transfer, amount of heat transfer is very high, we developed that. This regenerator is not available in India. Only Linde company from Netherlands, they are the manufacturer of regenerator. We studied, we observed the geometrical condition of the existing regenerator, then designed using Bengaluru based Intech DMLS company. There are many companies are available, but they did it in the low cost. This is a layer by layer 3D printing process. This is the first layer, this is the second layer, this is the final product. The SLM fabrication of layer by layer was used the development of regenerator. So the 3D printing, why I'm sharing these kind of things to you, it's also a part of thermal management device, but the cost is nearly 2 lakhs. This regenerator cost is 2 lakhs. We studied the performance of regenerator, performance of porous structure. So when the 3D printing involves, the cost is little high because it's in the preliminary stage. The metal 3D printing still in India, aluminum 3D printing is available in 2-3 places. The copper 3D printing is available in the Tidal Park, Chennai. Then the stainless steel 3D printing, wherever you go, it is available. In NIT Trichy, it is available. In Chennai University, it is available. In Tidal Park, it is available, stainless steel. So the metal 3D printing cost is very high, nearly about 3 crores to 30 crores. So that the fabrication cost is also very high. So when you print some small size, some reduced dimension level, then it is possible with 10,000 or 20,000. Anybody want to do PhD in this area? This area is very, very interesting area. It's very less papers are available, so that when you couple heat sink, 3D printing, PCM, nanomaterial, then it is very easy to produce minimum 5 to 10 papers. This is an experimental setup for the regenerator, right? So we inserted the regenerator in this. We studied the pressure drop analysis. So this is a research topic. Anybody want to do the materials, energy materials, particularly energy materials for thermal management. So you can use nanomaterial, PCM, heat pipes, EV battery cooling, electronic cooling, renewable energy, building insulation. Then if you add additive manufacturing, some green materials, thermal conductivity, mechanisms, right? So then another one is if you have some good friend in AI, ML department, collaborate with them. Chemistry, physics, collaborate with them. The chemistry, physics people definitely they don't have opportunity to do research, because we know as a first year faculty, science and humanities, they don't have much time to do research. You just go and discuss with them. Definitely they will help you in synthesis part. They know how to synthesize new nanomaterial. So instead of purchasing nanomaterial from the supplier, this new synthesis of nanomaterial means it's added value. Then the AIML, they help you to write the program or some kind of help to integrate artificial intelligence in your experiment. Right? With these three base science and humanities, AIML people and mechanical engineer, definitely you can publish many Q1 level work. It's possible, right? So these are all the references. Innovation starts with curiosity, and breakthroughs come from those who dare to push boundaries. Dive deep, question boldly, and let your research transform the world. So anybody dare to question anything from my presentation, please, I'm very happy to discuss with all. Anybody is there?
Participants have any doubt, you may ask.
If there is no question, I will share my slide to the coordinator. I will share along with my mail ID. You can ask any questions.
Thank you, sir, for your wonderful lecture. Sir, actually, I am from the thermal side and working as an assistant professor in Government Engineering College, Daman.
Government Engineering College?
Daman, sir.
Daman.
Yes, sir. It is
yes,
the UT administration of Dadra, Nagar Haveli and Daman and Diu.
Super.
Before your lecture, I was not searching very much about the sync part, but still I am connecting with you and means start my journey from here, sir. Thank you, sir.
Sure, sir. Sure, sir. Anybody is there? I will share my PPT. Anyway, it will help you because there is no literature in it. It's very hard to find some relevant paper. That is very, very difficult. Anyway, the few people are here to guide you, give support. Thank you, one and all. Thank you for this opportunity. Particularly, thank you, coordinator Prabhu.
Thank you, sir.
Thank you very much for this opportunity. So, see you soon. I share my lab PPT with you.
So participants have to wait.
So, good evening, sir.
Sir,
Sir, I am Arulkumar. Because some idea to do and only some details.
sir, voice is not audible, sir. Kumar, sir.
Hello? Hello?
Sir, tell me, sir. Your voice is audible, sir.
Okay, yeah. So, thanks so much. We have some work in relation to materials. I would like to deal with Dr. Rujuru, sir. I need to contact you. Hello?
Sir, voice is not audible, sir. While you talking to the resource person, sir.
Okay.
Repeat, sir. Can you repeat, sir?
Sir,
So otherwise, you post your
okay.
question in a chat box, sir. He will tell you, sir. Thank you, sir. Thank you for valuable speech towards with us.
Yes, sir.
Okay, sir.
Any questions from the audience?
Sir, he asked in chat box, sir.
Yes, sir. Mr. Sivakumar, sir, asked about surface coating. Surface coating means it's very interesting, sir. If you coat some nanomaterial, inclusion of graphene and CNT, then it is very, very effective. Only thing we need to ensure the stability and life. That is very important. If you have that kind of coating, it's very, very useful for thermal management aspect. Whenever it's a surface coating mainly depends on the viscosity. You need to control the viscosity there. So it's a difficult task. If you control viscosity, then the heat transfer aspect, that effect will give the negative effect. Whenever you take care of viscosity, we need to accept the loss in the thermal conductivity. So it's a very interesting research area, sir, the surface coating. Anybody working in the area of surface coating, there is a potential possibility of developing experimental setup in the thermal management. It's very, very easy. Because PCM, we have a leakage issue with PCM. The efficient surface coating eliminate PCM from the heat sink. That gives better efficiency. But the stable coating, the preparation of ink, the viscosity of the ink matters. Anything else?
So thank you, sir.
Thank you, sir.
Thank you, sir. Thank you for your valuable speech, sir.
Thank you very much. Shall I leave?
Yeah, sir.
Huh?
Yes, sir. You may leave, sir.
Okay. Thank you.
Thank you, sir. Participants have to wait. The next section, Ganesh Babu sir will join shortly.
Hey team, good afternoon.
On this occasion,
Yeah. Yeah. Prabhu, could you able to hear me? Ganesh?
good afternoon, sir.
Yeah, good afternoon, sir.
On this
So,
momentous occasion, I would like to welcome our today's second section resource person, Mr. Ganesh Babu, sir. Yeah, sir.
yeah, team. I really feel very glad to come to this particular seminar session, and and it's going to be a nice experience for me too. And also, I hope I will keep everyone. I promise it will be a good, fruitful session for everyone. Please interrupt me if you are not able to hear my voice, because I don't think so. My network connectivity is so strong. Please, if whenever you are missing me, or if you are not able to hear my voice, please rise up and let me know, so that we can look back into the network. Okay.
Okay, sir.
Yeah. So I will share my
Shall I
screen.
introduce, sir?
Yes, sir. Yes, sir. You can go ahead, please.
On this momentous occasion, I would like to welcome our today's second session resource person, Mr. Ganesh Babu Palanisamy, sir. Tech Lead Engineering, Ingersoll-Rand Technologies and Services Private Limited, Bengaluru. He has a vast experience in the field of IoT integrated with mechanical machines. Despite being his busy schedule, he has given considered for our FDP. Once again, I welcome you, sir. I will hand over this session to our resource person, Ganesh Babu, sir.
Yeah. Thanks, team. Could you able to see my screen? Can anybody say where it is?
Yes, sir. Visible, sir. Sir, can you make it zoom, sir? It's
Okay. Is it fine now?
yes, sir. It's visible, sir, but the letters are in small letter. Letters are looks very small. While
Okay.
we are
uh, I have zoomed my presentation to the maximum limit, I would
okay,
say.
sir.
Sure. Okay. So, team, coming to the today's session. Before you know that this particular session we are talking about IIoT, that is Industrial Internet of Things. Okay, so start before going into this topic, I would say that this will be around a 1 hour topic, and I have a few important points that related to IIoT to share to the larger audience. So maybe this will be definitely a fruitful session for faculties, and also this would be helpful for students as well. So this particular session will definitely give some glimpses how this future world is going to be. So it will show some of the biggest things which we need to focus right now, and what are the things that we need to give for our students, so that future this mechanical industry stream will be in a better position, and also they will be getting into a good jobs. This is more like understanding the industries. So it will be a good I hope it's going to be a good session. So before getting into the session, I just give some quotes that big data is not magic. It doesn't matter how much data you have if you can't make sense of it. So IoT is nothing but it's a data. It's the biggest elephant. So if that doesn't make any sense, if we does not use it in a proper way. If we use it in a proper way, it will be a biggest boom to the humanity, mankind, and for next level developments. So today's session, I just these are all the points that I am going to talk about, or I'm going to give a slight touch base on what are all these things. Okay. First I will introduce myself, and then next I will go into IIoT general concepts. What is IIoT? Very basic level outline concepts. I will just touch it up, and I give some introduction on Ingersoll-Rand product line, and what are the products we are having, and particularly what product we are going to talk about. Okay, in IIoT general concepts, it will be very generic, and I will get into one product line which Ingersoll-Rand uses IIoT in the market. Okay, so before going into IIoT, definitely without understanding the function and working of the product, without understanding that, it is very difficult to understand IIoT. So definitely for that I have some videos which will help in understanding the product lines. So then I will talk about what without IIoT, how the world will be, that is what currently how we are operating. And with IIoT, what are the benefits? And coming into more technical, what are all the measuring elements and methods that we use for making the IIoT data collection? So next comes the electronic systems. What are all the electronic systems required? How the electronic system helps in collecting the data information from the field. Then comes MQTT server. I will just give a small introduction on that server side. And next comes how cloud design is connected with IIoT. And finally, what is DevOps and how that DevOps will be helpful for the what role this DevOps plays into IIoT. So these are all the major topics that definitely we need to look into before going. So coming to the self-introduction, my name is Ganesh Babu. I have totally 18 years of experience in the mechanical industry, and out of which I was with the past 8 years I am associated with Ingersoll-Rand as a technical manager, Bangalore, and I'm just handling a small team, a design team, and where there is most of the work lines will be like new product developments and for ETO changes, and we sit at Bangalore and we are supporting the plants located at US, Enon, and North Carolina, and also for the China plant we are supporting. So this is my official introduction. So with this I just jump into the IIoT concepts. Yeah, just before going into one specific example, we will just have what in general what is IIoT. It will be a basic concept. Just we will have a touch base on 2-3. I have 2-3 slides to explain what is IIoT, and then we will go in. We will take one product line, and then we will look that product line in detail for analyzing the IIoT subject. Okay, so team, I think people are following, right? I'm connected, right?
Yes, sir.
Yeah, okay, thanks. What is IIoT? IIoT is the Internet of Things, that is a network of physical objects or things embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange the data. So basically it is a collection of data. That is the Internet of Things is mainly we will collect the data and we will process the data and we will present it in the useful way. and it allows the object to be sensed and controlled remotely, and existing network infrastructure, and creating opportunities for more direct integration between the physical world and the computer-based systems. So this is just a generic statement. So it's a typical IoT ecosystem, how it works like. So if you see that you coming to the left hand side, we are the end users, whatever the products like we use in our day-to-day life, maybe mobile phone, cars, and home appliances, uh, everything. So what are the data that we can able to collect it, that will be collected, and it will be pushed into the communication processing devices, and from there it will be put into the cloud system, and from there it comes to the final DevOps. DevOps is nothing but a presentation or visualization, whatever we can say, the method of presenting. So that's with the data whatever we have collected from the cloud. So structure of IoT. IoT can be viewed as a gigantic network, and there are multiple things are there to connect and get the data, like tagging things, that is real-time traceabilities, and feeling things like sensors. Example, temperature, we can able to sense it, and also the proximity. RFIDs are used for proximities, and shrinking things like miniaturing and nanotechnologies, and things like embedded intelligence. So like maybe I'm going to be very particularly give one example just on feeling things, that is the sensors. So with that I will show show a real-time example, so that it will be helpful for understanding the IoT in a better way. Yes, this slide is a little bit important, I would say. So coming to this triangle pyramid. Okay, yeah.
And the slide is not visible, sir. I think last PPT it shows that.
Okay, I just I will once again I just come back. Sorry, I think I will reconnect once again. Maybe I will come out and connect back. Hello. Yeah, Prabhu, could you able to hear me?
Yes, sir.
Yeah, I having some difficulty in sharing my screen. It is saying that it cannot be shared. Can I put the PPT in the WhatsApp so that you at least you can share it?
Yes, sir.
Yeah, one. Team, whether my screen is visible?
Yeah, sir, visible, sir.
Oh, now I am showing the slide knowledge management. Is it that visible?
Yeah, sir, visible, sir.
Okay, okay. Sorry, I don't know when it got dropped. Please interrupt me whenever you are not able to see this slides. Okay.
Okay, sir.
So I just recaptured whatever the things I have shown. First, we have started up with the message, big data is not a magic, but it has to make a sense. And I have given a synopsis about this, self-introduction, IoT concepts, product explanation, function videos, without IoT, with IoT, and measuring elements, electronic system, MQTT server, cloud design, and DevOps. So these are all the points I have explained, just to touch base. And what is IoT and how ecosystem works. Okay, so then structure of IoTs, and now I am in the slide knowledge management. So this is a bit important slide to be concentrated. So first it is whenever data is collected from the field or anywhere, so it is a data. Data is a raw data. It's just a symbol, it's just a number, and it's just a statement kind of thing. It has no meaning. When we add some meaning to that particular data, it becomes an information. So mostly answers to who, what, where, when questions, the very simple questions. Then it becomes a data becomes an information. When that information answers how, then that information becomes a knowledge. So next, when it addresses to the question why, then that knowledge becoming an understanding. Once that understanding comes, it is a wisdom, or it is the innovation. So this is how from data we are migrating to innovation. So this is how first to get into an innovative any inventions. Data is the mother of invention, I would say. From data only we can able to give a discrete solutions to any kind of problems. So for this, IoT plays a very, very important role in collecting the data. So some of the applications, building and home automations, manufacturing, medical, healthcare system, media, and environmental monitoring, infrastructures, energy management, transportation, and better quality of life for elderly people. So these are all some of the applications of IoT. So that's all about general concepts. So from this I would go to next topic, that is on Ingersoll-Rand products. We will take one example and how the IoT works with the real case example, I would say, with that how it works. So before going into IoT, first we need to understand the function of the product. Without understanding the function, it is very difficult to understanding IoT is of no use. So I have 4 videos, just to it won't run for a long time. It may be a 1 minute or 2 minute videos. So with this we can able to understand the product. And I am for this session I have taken a pump called EMAC dosing pumps. Dosing pump, Ingersoll-Rand has a lot of acquired companies inbuilt. So one of the company is Milton Roy. So Milton Roy has a product line called dosing pump. Dosing pump is used for dosing application, like for example in a pharma industry, for example the Dolo 650. I'm taking one known example, that is Dolo 650. How much amount of that ingredients, for example, how much amount of ethanol or propanol that has to get mixed into the tablets. So that in an accurate manner. So for that, this dosing pumps are used. So that we are going to look into. So, team, could you able to see my screen? I'm going to put it. Display a video.
Yes, sir.
Okay, sure. Thanks.
So video is shown, sir, but voice is not audible, sir.
Sorry?
So only video is shown, sir. The background
audio வரலீங்களா?
வரலீங்க, sir.
But okay, but நான் இந்த chat boxல ஏதாவது போடுறேன். எனக்கு இந்த 4 லிங்க் மட்டும் நீங்க யாராவது பண்ண முடியுமா? அந்த chat box போட்டிருக்கேங்க. இந்த 4 வீடியோ மட்டும் ப்ளே பண்ண முடியுமா?
ஓகே சார்.
ஓகே.
Sir, actually for audio, I think we want to share the tab, the particular tab which we want to play the video, sir, while sharing. Thank you.
Okay.
Water treatment applications. The new PD series builds on years of industry experience with new technologies to handle the most challenging applications while providing convenience and value to your process. Available in 2 models, the PD series meters chemicals accurately with the reliability you'd expect from LMI. The manual model provides easy-to-use features, including improved drive mechanism, simplified capacity setting, advanced electronics, and robust fast prime liquid ends. Not to be outdone, the enhanced model includes additional features that fit seamlessly into your process, including a full color display, external control inputs, calibration assist, system and user totalizers, and stay prime degassing technology. The PD series sets the industry standard for reliability, precision, and performance. Trusted by water treatment professionals for more than a generation, the new PD series will continue to earn your trust for years to come. Contact your local stocking distributor today to learn more.
Amazon label.
Team that audio is not there.
நம்ம வாங்க முன்னாடி வாங்க. ரெடி.
Hello. Prabhu, I think we have covered all the videos, right?
So last video, sir.
Okay.
Iwaki metering pumps are integral to the worldwide dosing pump market. As part of an extensive product offering, our electromagnetic metering pumps are synonymous with quality and performance, resulting in a record of high reliability. The EWN series is Iwaki's latest addition to the metering pump product line, aimed at further simplifying worldwide support. Only from Iwaki is true high-speed chemical feed a reality. 360 stroke per minute operation coupled with variable stroke length control allows the EWNR the most precise control and adjustability available. The enclosure of the EWN series has been designed with consideration of the water and dust-proof specifications of the IP65 standard. A sealable cover over the controller further allows the pump to be used in many diverse environments. The electromagnetic drive unit of the EWN series is much smaller than mechanical drives and offers much more control adjustment. Two types of drive units are available, the B-type and the C-type, providing for unique output requirements. The EWN series launches Iwaki's new Universal Connection System. A new coupling nut design allows for any size connection available, while preventing the twisting of tubing during connection. There are 4 standard liquid end materials available within the product series: PVC, GFRPP, PVDF, and 316 stainless steel. These core materials allow the best combination of materials for any application at the most economical rate. In addition to the standard pump line, the EWN series includes specific models targeted to unique applications. The high compression pumps were designed for chemicals that outgas, such as sodium hypochlorite. Increasing volume per stroke and decreasing dead volume increases the compression ratio, making a pump design excellent for pumping chemicals that contain a lot of gas. The high-pressure pumps were designed for feeding chemicals into applications at higher pressures than the standard pumps. The high-viscosity pumps were designed to efficiently pump viscous materials such as polymers and other coagulants. The pump controller utilizes several control methods for output control. Manual control is achieved through stroke length adjustment or pump speed adjustment, or a combination of both. Stroke rate is displayed as a percentage of full speed or one of several flow rate units. In addition to manual control, the pump is also capable of being proportionally controlled by either analog or digital input signals. The multiply control can be used to set multiple pump strokes for every digital input. The divide control allows the pump to stroke for a predefined number of input signals. Programmable analog control allows control of a pump stroke range between any 2 arbitrary points of the 0 to 20 milliampere scale. The EWN R-Type is the main part of the series, encompassing all the features previously described. In addition to the standard functions, the EWN W-Type controller is equipped with programs specifically for water treatment applications. With a sensor wired directly to the pump controller and able to perform functions typically requiring a separate controller, the EWN R-Type achieves significant cost savings in both initial cost and maintenance. The EWN W-Type was developed as a successor to the EHW type and is available in 3 options: the WPO, the WEC, and the WCT types. Using a larger LCD display, the EWN-W provides more information to the user in one display. The EWN-R and the EWN-W pumps accept universal voltages and can be used worldwide without restriction from variable voltages or certifications. Iwaki metering pumps play an important role across the globe. Building on our successes, experiences, and long pump history, Iwaki strives to continue to provide products and solutions for the water treatment market through continuous improvement. Now and in the future, you can rely on Iwaki for your metering pump needs.
All videos are finished, sir.
Okay, sir. Sure. I will take the control. So just again, I'm facing some issue in showing a 3D model. I'm trying to share a 3D model, but this is not allowing. Please let me know if you are able to see the 3D model of the pump. Yeah, okay. So the video, whatever right now we have seen is the same this metering pump or dosing pump, we call it. It is generally used for the chemical application. Controlled volume. We have to dose to the water treatments in pharma industries or in any of the chemical applications wherever we need to mix the chemicals at a proportionate ratio. So this pump is used worldwide. So for this, I'm just going to explain how the maybe people may understood from the videos how the basic principle of working would be, but still I would say this is a electromechanical pump. Okay, so this is outside is just a we can divide this into 2 categories. One is drive end, this is liquid end. Okay, so I would say like this, I would divide like this. This side it is drive and this side is liquid. Okay, liquid or pumping end. Okay, this is drive side from where power is generated and the motion is created, and from the liquid end from where the pump is transferred from one point to another. So we divide this into 2 categories, that is liquid end and drive end. Okay. So now I'm sectioning this pump to understand what are all the things inside it. Okay. So as I told, this is an electromechanical pump. So this is called front panel. Here all the electronics will be available. So with this, the power is given to a coil over here. This is the coil, and when this is the one is a coil, and whenever the current get into the coil, it will magnetize this armature, and whenever this current is supplied, this becomes a magnet and pulls this iron piece. See the spring element, this gap will become 0. Okay, the gap will become 0 when power is given to this coil, and this armature will become a temporary magnet, and it will attract this metal portion. So but this metallic piece is connected with the stem, and the end of the stem is a diaphragm. Okay, so this diaphragm reciprocates, and because of this reciprocatory motion, the fluid is pumped out. I just draw a diagram. So this is diaphragm, D for diaphragm, and whenever the current supplies, this become a magnet, and it is this metal portion, iron portion, just make it as iron portion, is attracted towards this armature, and forward stroke happens, and this forward stroke is just for 100 milliseconds. Okay, this is just 100 milliseconds, and after that 200 milliseconds it will be for return stroke. That is, the power supply will be cut to the armature so that this magnet will become demagnetized, and the spring will push back to its original position. So it's return. So because of this reciprocatory front and back reciprocatory motion is created inside the pump. So because of this, suction is created, and the fluid will be flowing from inward to outward. So this is the basic working principle for this pump. I think you can able to follow this with a very simple mechanism. Team, any doubts or anything you want to ask to me based on the function of this pump? If not, I can move to next topic. Okay, fine. So without IIoT, so we can able to control the stroke length, how much length it has to go forward and how much length it can come backward. So that is called stroke length control, and the number of strokes, that also we can change based on the electronics here. So that is a normal pump function. That for that only these two knobs are given. Okay, so this knob will helps for the controlling the length of the stroke. This knob is this basically backside of this there is a one potentiometer similar to our fan what we have in our homes. Similar to that, this is a potentiometer which controls the speed of the front and back movement of the diaphragm. So these two are the direct control that controls the flow of this pump. Okay, so this is a manual pump without IIoT. So what we can, how we can make this pump as a smart pump? For example, our customers are some Tata and also a lot of petroleum companies like HP, Indian Oil is also the customer to our to this kind of product lines. So most of the industries are located in a very remote area, which we cannot control it, and every manual presence is very, very important. It is a very big industries, and these kind of pumps, thousands and thousands of pumps are used. This kind of pumps are used in that industries. So where the manual presence is very, very important. Every time human presence is required and need to go to the nearest of this pump and then have to visualize and take the readings, whether the pump is working fine or it's not working, that a human presence is very, very important. And because of that, companies are spending huge as well for the labor management. So that to reduce those things, and also to control these kind of pumps from a remote area, and also to visualize any malfunctioning is happening, and also to identify how many cycles this pump has run. For example, I think you might have come across two things. One is the maintenance, normal maintenance, that is we can divide into two types. That one is destructive type and another one is preventive type. So this particular diaphragm will go off after a certain cycle. See, this is the diaphragm. So after 1 lakh cycles, this particular diaphragm will go off, and we don't know whether how many cycles it has went, how much per day it is working. That also we don't know. So to get into these things, we will be putting some proximity sensors, and also we can count this number of cycles. So whenever, for example, the life of this particular diaphragm is 1 lakh cycles, if I'm able to identify the 90K, when this 90K cycles are reached, and it is an alarming sign for me, so that I can change this diaphragm. So basically from destructive maintenance to, that is to, it will become a preventive maintenance. So no need to stop the line. We can, in a planned manner, we can make the maintenance in a proper way. So no need to stop the production. So this would be helpful with the help of IIoT. So I'm just jumping into next product line. The same product which you have seen in the 3D model, that is without any IoT features. Team, could you able to see my PPT?
Yeah, sir, visible, sir.
Yeah, okay. So now I moved from SolidWorks to PowerPoint. So the same pump which I showed in SolidWorks, the 3D model, that is the old one, but that has been changed into IIoT version. This pump now became a smart pump. So what we have done, what is the inside things, what are the technical things that has been focused to make this pump more interactive with the end users or the customers. So that is what we are going to look into the next upcoming slides. Okay. So what are the parameters we are taking into consideration? First is temperature, because this pump, after running for 6 to 7 hours, it will get heated up. So it is very much important to stop the pump once it reaches 75 degrees centigrade. We should not allow the pump to run beyond 75 degrees centigrade. This is usually done through spot thermometer. The person has to go near to the pump and has to put the spot thermometer over the pump and has to measure the temperature, and then has to switch off the pump. So that will be taken care by putting one temperature sensor into the pump, which gives the reading of the temperature, and that will be given to the DCS room, and from the remote area we can able to on or off the pump. So first parameter which we are going to control is a temperature. Second is the volume of the pump. So volume, in this category of pumps, the stroke length and the speed. Stroke length and the speed is directly proportional to the volume of the pump, that is, it got displaced. So volume is also we can be able to control over this. And the speed, and as I mentioned, there is a potentiometer behind this electronics that is in the front panel, whatever you are now seeing. Behind this there is a potentiometer that previously we used to control it through the knob, but with this IoT's features, we can able to feed through program, and we can control it through the button, or we can control it through the software also. So that you can able to see there are some buttons given in the bottom of the knob. So this could able to increase and lower the speed of the pump operation. Also, the stroke length and the percentage also can be easily controlled. So there are up and down soft buttons, and the remote control also available for this IoT features. And there are some error adjustments also taken care into this, because there will be some, for example, this pump can, with water, it can give 50 LPM. Example I am saying, with water, it can give 50 liters per minute. But with the any other fluid, that I would say the water is 2 CST, centistrokes. But if we are going for some higher viscous fluids, for 30 CST, 40 CST, so such kind of fluids, the flow will get dropped. So in such cases, we need to make some error adjustments in the display. So that will be also taken care in this IoT series. And there is a buttons for on off, and that also remote buttons is also available for switching on and switching off this kind of IoT pumps. So just this pictures shows first picture on the left, pump D92D0001. This is nothing but the pump identity or the name. In a DCS, that is a distribution control room, we can able to identify this particular pump, because I told you in the refineries there are thousands of such pumps are installed. So this every pump should be named. So for that, D92 is the name of this pump. So from remote, we can able to control the D92 pump, and we can able to see the temperature of the pump. The second picture, it is saying that temperature, it is 27 degrees centigrades. So now there is no harm for this particular pump to run. So how this temperature is measured? So inside we are placing the sensor. Temperature sensors are placed near to the coils. That is the I explained through the SolidWorks file. That is, the coil is there and armature is there. So near to that, your temperature sensor is placed, and which is able to capture the temperature and it give it on the display. So next comes the stroke length adjustment. So plunger, this is, if you say, I told the flow is directly proportional to the speed of the diaphragm moving front and back. That is called number of strokes per minute, and also the stroke length, how much length it travels. So that based on that we can able to vary the flow. So for this kind of pumps, this is a dose. I told in early, it is a metering pump or dosing pump. We call it as a metering or a dosing pump. So only this metered quantity, for example, this pump can give a flow range from 10 LPM liters per minute to 40 liters per minute. So, but for one particular manufacturing in the pharma industry, for manufacturing a Dolo or any other some other tablets, that flow may require to control to in between from 10 to 40, maybe example 33 liters per minute. That is the exact requirement. So how we can control that? So for that, there is a manual knob is there, but that we can through putting some stepper motors and potentiometers, we can connect that to the DCS, and we can control the rotation of the knob through remote also. So the plunger percentage you can 100% right now, this can be reduced to 50% based on the flow requirements. So next comes this correction factors. This error factor, basically what we mainly it is used for different viscous fluids, as I mentioned earlier. So different fluids has different viscosity, different chemical has different viscosity. So but we need to have the control over the flow. If viscosity is more, the flow will get reduced. So to control that flow, we need to put some error factors, and then we have to make that compensated. Okay, so now I have covered the measuring elements or the parameters, that what are all the parameters that we are measuring inside the pumps. Those parameters has been discussed. Okay, so now the data are collected, and we need to convert the data into information. So what we will do? So for that, we have a thing called MQTT server. So MQTT server is very important in whenever you go for IIoT. Okay, so sorry, I don't have any slides for showing that MQTT server home page. So it is nothing but the data collections, whatever it is collected from the pumps. Or for example, in a refinery, I have 100 pumps. All these 100 pumps data are collected, and that will be given to the DCS room. From the DCS room, that MQTT server will manipulate the data to the required format. I tell you one more thing. For example, temperature. Inside the pump, the temperature is 85 degrees centigrade. But I have put a sensor which has, it will give you 4 to 20 milliamps. That is the output. That either 4 means it is 0 degrees centigrade, and 20 milliamps means it is 85 degrees centigrade. So from the sensor, we can able to get the data in the format of current or voltage. But that cannot be understandable for the end users. To understand, for the end user understanding, this current format, that is the sensor output, need to be converted into meaningful values. For that, MQTT server is used. It's very important to understand the working of MQTT server. Lot of programs are used, lot of logics are used in MQTT server. Okay, from there, for example, I'm having a yes. Okay, so for example, yeah, I'm just reiterating because this point is very important when compared to IIoT. So whenever I'm putting a temperature sensor into the machine, that machine gives the output in terms of current, milliamps or volt. But I have put a temperature sensor. But that temperature has to be get converted into an temperature value, for example 35 degrees centigrade or 40 degrees centigrade or 85 degrees centigrade. To get that machine data to convert into a meaningful value, some logic need to be fixed, some programs has to be developed, and that has to be fed into the MQTT server. So this is the function of MQTT server. So this is actually placed on this particular server need to be available near to the virtual machines where we collect the data. Now the data are converted through MQTT server. Data are converted into information. So that is the very important point here. So next thing, I'm switching to next topic, that is cloud. So cloud is nothing but, it is, again I would say, it's a collection of information from various places, and it just fed into one space in the server, in the global server unit. For example, there are a lot of cloud providers are available worldwide. We are currently working with Azure. Same wise, we have Google, we have with Orkut. So a lot of IoT space providers are available, for which we need to pay to the corresponding providers. For if we since we are using Azure, we will be paying for the space for whatever we are utilizing. This is nothing but this collects the data from MQTT server. Whatever the data that are collected in the MQTT server is pushed into the cloud. So the cloud basically collects all the information related to the virtual machines, and it will be having in a what to say, it is a raw food. I would say it is a raw food. It's not a cooked food. We cannot eat it. That means we cannot interpret what is the actual condition of the sites. So it will be in a raw data. But that raw data need to be converted into a understandable format. For that, DevOps is required. So, for example, I have installed 5 pumps in the customer site. This A92, B73, D92, UC11 and V13. These are all the names of these pumps. Okay. Yet I just log in into my cloud login credentials. Whenever I log in into my cloud credentials, with the cloud credentials, whenever I log in into my cloud space, I can able to see all these 5 pumps, status of all these 5 pumps. Currently, whatever this particular snapshot is saying that all these 5 pumps are in off condition. And when they are in off condition, what is their last deliverables are given below. That is, what is the temperature of that pump when it was switched off. It is 29. For example, I'm just taking this A92 pump model. When this pump is switched off, what time it is switched off, what date it is switched off, that information also will be provided. Which location this particular pump is right now available is also provided. If this location is changed, it means that customer has disturbed our pump without the information. So this will affect the warranty state also all those compliances also come into picture. So making that so location is also very important. Without the notice to the manufacturers, customers also should not disturb the pumps. They should not dismantle the pumps. If they did anything, we can able to track from our remote locations. And temperature, speed, what is the flow rate it has run, and what is the pressure it has worked for, and at what stroke length the customer has used this pump. So all these informations are completely put in the table format. And next, this will also give this if you look at this particular temperature, these are all the various icons available in the DevOps area of the cloud. So whenever I click into the temperature mode, so I can get this table. This table will take data for every 120 seconds. This data will be collected and a graph will be plotted automatically. So we can be able to understand when the pump is used at high temperature and what time and everything will be, we can get it in the graphical format. So for this data, that raw data getting converted into a presentable graphs or any dashboards or any graphical representations, we call it as a DevOps. So we also in this cloud area, we can be able to reduce the speed of the pump or increase the speed of the pump. We can switch on the pump or we can switch off the pump at any time, and any alarms also we can give for any malfunctions currently. if happens to the pump, that we can able to identify immediately, and it will give alarm. This can be, see, this also we can use it in our mobile. So whenever the pumps, any of the pump is getting a malfunction or any other emergency signal is popped up, immediately in our mobile we can get the alarms. So what are all the additional devices? In addition to the normal function of the machines, what is the special devices required for these IoT features is that that ESP32-bit chip is required for collecting the data from the machine. So this particular chips, microcontroller chips, will be installed in every pump, every single unit of the pump. That helps in collecting the data and pushing it to the MQTT server, which nearby servers. It not only MQTT server, the data can be transferred from every individual pumps to the server using Wi-Fi method. From SIM method also we can able to transfer the data, and also RS-485 cables are the general methods how we can able to transfer data from each pump to another. For example, most of these refineries are located in very remote areas where this network providers will not be there. So we cannot use SIM cards over there. So in such cases, even in certain refineries, there is no Wi-Fi at all. So how we can able to transfer the data from the pumps to the main DCS, that is a controller room. At least it has to travel 4 to 5 kilometers inside the refinery itself. So in such cases, RS-485 cables are used for transferring the information from the pumping unit to the MQTT server. So that's all the overall thing I have for today. So team, if you have any questions, please you can put forth to me.
So I have one doubt, sir.
Yes, please.
Sir, can you share the cloud data with the customer? They can monitor their performance of their pump.
We currently how we are managing is we have one cloud for which Ingersoll-Rand is paying. If customer wants that data, if they want to, they also need to monitor and control the pumps, means they have to pay and get the cloud space to us, in which we will configure our DevOps to them. So in such cases, customer has to pay to the particular cloud space provider.
Okay, sir. If there is any problem occurred in that particular pump, means they will ask you to rectify it.
Yes, that's what. Even that cloud we can install, we can have it in our mobile, and alarm comes up immediate. We can one more thing. This is also helpful for this service people also. When this pump got troubleshooting, when it has happened, when the pump got stalled, from the date of stalling of the pump, how much time we have taken to service that kind of pumps, all the informations are recorded. So it is very upfront. Nobody can cheat, or nobody can delay on the work. So it is very useful in things also. So moreover, if customer has done some mishandling of the pump, for example, for that only we have a positioning sensors, GPS, are also provided with the every pumps. so that if they dismantle the pump, இப்போ வந்து ஒரு பம்பை இன்ஸ்டால் பண்ணிருக்காங்க, அந்த இடத்துல இருந்து இன்னொரு இடத்துக்கு அவங்க எடுத்துட்டு போயிருந்தாங்க கூட நம்ம கண்டுபிடிச்சிடலாம். அவங்க தொடக்கூட கூடாது பம்பை. அதுதான் வந்து ட்ரேடிங் பாலிசிஸ்ல நம்ம பண்ணியிருக்கிறோம் ஆல்ரெடி. வந்து இதுதான் நம்ம பாலிசிஸ் வி ஹவ் சைன், ரைட்? ஸோ அதுல வந்து அவங்க என்ன கை வச்சிருந்தாலும் we can able to identify with this IoT devices.
Okay, sir. So participants have any doubt, you may ask. Okay, thank you, sir.
Okay. Thank you for everyone for hearing my seminar for patiently, and thank you, and have a nice day. Bye.
Thank you, sir. Participants have to wait another 10 minutes. The next resource person have to join at 4:30. Okay, now I send the first and second section feedback to you. So all of you have to fill the first and second section feedback. I will post it in chat box. Okay. Nirmal sir, are you available, sir?
Okay.
On this momentous occasion, I would like to welcome our today's final session resource person, Mr. Nirmalkumar Arputharaj, sir, Senior Quality and Regulatory Engineer, Medtronic Engineering and Innovation Center, Hyderabad. He has a vast experience in the field of quality inspection of medical devices by using latest technologies. Despite being his busy schedule, he has given considered for our FDP. Once again, I welcome you, sir. I will hand over this session to our resource person, Nirmalkumar, sir.
Hello, Prabhu. Thank you so much. So I believe like you guys can hear me. Can someone acknowledge you can hear me and you can see me as well?
Yes, sir.
Okay. So I would like to thank like the ATAL. So it is basically right. I can see that you guys are working to bring up the things that we are having from the technological advancements, right, in the manufacturing industry. And this is really a great initiative, and I would like to appreciate that. With that note, I think I can start my presentation. Okay. So now the topic that that I have been prepared or I have been asked to prepare is about the manufacturing technological improvements that we do have in healthcare industry, right? So basically, I believe, like Prabhu, you can just help me to understand the audiences are pretty much from mechanical engineering background,
Yes,
or
sir.
maybe from research, and yeah. So you guys might be doing some researches, and you might be knowing some or walking through your curriculum of mechanical engineering in your bachelor's or master's degree. And I really kind of happy, like so many lectures I used to give, but maybe this is the team where actually the message should go. Okay, so I'm opening my presentation. Someone please confirm if you guys are able to view this presentation.
Yes, sir. Visible, sir.
Okay, fine. So maybe I'll try to like kind of walk you guys through the experiences that I have and the basic things of mechanical engineering scope, right? The engineering scope that what you guys are learning So how this scope of work will be utilized or kind of derived into a medical device engineering field, right? So nowadays, medical device engineering is a vast place where so many magical technological solutions and evolutions are happening, not only from the software perspective and also from the mechanisms perspective, right? So the overall opportunities, maybe you guys may be thinking like these are all the opportunities that we have once you're coming out with your like mechanical engineering graduation, like healthcare industry, automobile, cement, steel, power sector, maybe aeronautical, oil and gas, hydraulics and pneumatics, biotechnology. Yes, of course, we are into it, and defense sector and manufacturing industry, and then maybe teaching. Right. So with these opportunities, maybe I do have a situation. Maybe 14 years back. 14 years back, like 1 minute. 14 years back, when I was completing my Bachelor of Engineering, then I had I was not having that much of awareness on what all opportunities we do have. Okay, maybe this is just a heads up that I would like to bring you. So I have completed my mechanical engineering, BE in mechanical engineering by 2010. Then I have joined a company in 2011 where I was working as a GET, and 3 years I was working. While I was coming out, I was the production in charge. The 3 years I was working in a steel manufacturing industry, which is a TMT bar manufacturing industry, that the construction bar we used to construct our houses and all the buildings and all, right? So the TMT bar we used to manufacture. Then from that, I was good in design. So from that first 3 years, then my career shifted to the mechanical device engineering world. Then I didn't have an idea of what a mechanical engineering person can do in a medical field or in a medical device field and all, right? So all these questions I had, but they hired me, and I was working for one of the companies named Baxter Healthcare, which is located at USA, but I was working from Chennai. So you can have two things. One is you can understand devices engineering side, one side, and you can have the pharmaceutical related stuff in the other hand, right? So what are all the drugs, all these things, what you are using, what we are using, the drugs, the solutions, all the edible things, right? The medicines, medications, all these things, all kind of going into the pharmaceutical industry. And what all the devices that I refer is, if you go inside a hospital, what are all the devices you are seeing? All devices are like medical devices, including your gloves. The nurses or the healthcare professionals, they used to have the gloves, right? It is a class 1 device until some implants that the people will be having, like the stent, the bolt nuts, and also all these things are like medical devices or equipments, right? So it is a very vast area where I would recommend you guys to focus in getting into that medical device engineering world. Maybe I'll just like to let you know mechanical engineering in medical device manufacturing, or maybe in the scope of medical device. You can see the global medical device market is like 2022 to 2024 consistently, if you see, right, 350 billion of increase in growth rate, you could be saying, like the increase in rate in growth. I used to say the growth is not like kind of only organical growth, it is kind of inorganic growth as well. Like the growth is enhancing the lives, and also like from the transaction perspective, from the money transaction perspective, the growth have been expanded like kind of consistently 5% it is getting increased, right? And still it is getting increasing. So the mechanical engineering team, mechanical engineers in medical device engineering world is very critical. The mechanical engineers are very critical when a device or component is getting manufactured and getting like kind of used by a patient or a customer. Okay. So basically, I don't think I'm still able to like kind of, you guys can still able to hear me. Am I lost? No. Still you guys can see the screen and hear my voice?
Yes, sir.
Okay. Just start of confirming. So basically, a mechanical engineer will be hired in a healthcare industry. A mechanical engineer will be hired, maybe can be a BE person, ME person, or a person who has done a research or PhD something. They will be hired in a healthcare industry basically for three things. One is they help, they need our help, they need mechanical engineers help in research and development, or they will be taking our help in a new product development. So research and development is just researching, right? Only research and give the data. So I have done a research on this particular component, or I have done a research on this particular maybe a device, and this is the result. So I have done a benchmarking, what are the better similar products we have in the market. So I have done a benchmarking. So I have seen like these are all the changes that we can bring in, and these are the customers, those who are like kind of unhappy with the device, or they are giving these voices of concern, or maybe a technology has been improved in, instead of doing in this way, we can adapt to a new process, or a new way of doing a thing can be done for this particular device. All these things can be all these things can be done within the scope of research and development, right? So they will just do an analysis, they will research some data, and they will give the outputs to the organization. So for this, they need mechanical engineers. And the second thing is new product development, right? There are so many new technologies is coming up, so that a product is getting evolved to a new version of product, or completely a new product itself is getting discovered or invented, right? So basically, if we are inventing a product, we will be filing a patent. So the patent board will see, okay, this is an innovative idea or thought or a concept. Then they will be just working on to that particular idea. Or else, maybe a company will be expecting, okay, there's a problem, customers are having some problem, and we do not have a machine, or we do not have equipment, or we do not have any medical device component to help that particular need, right? So we can create a new product to help that particular customer need or patient need. So in those kind of scope of work, right, they will be hiring mechanical engineers to do a new product development. And sustenance engineering. So what is sustenance engineering is, already the product is developed, already the product is been in market for so many years, but still the product has to be sustained in the market, correct? The product should be manufactured appropriately on the daily lot, on the daily shift. It should be in line with the requirements, it should be in line with the specifications, and it should be tested properly, and it should be like kind of from the raw material, maybe if the raw material is coming, right, the quality engineer might be a mechanical engineering holder, right? Maybe the person will be taking the raw material and he will be testing in the lab, okay, these are all the input parameters that is expected, and this is the raw material I have received. Maybe, for example, that's a syringe if we need, right? There is a, maybe BD is a company, or so many companies are manufacturing syringes and needles. So if it is a syringe that is already in market, everyone knows, but why do we need maybe an engineering background person towards it? To maintain its credibility, right? So any raw material is coming, like low density polyethylene or high density polyethylene is coming, the engineer will go and do the test in the lab, and they will say, this is appropriate specification. The components are appropriate, and I have done a tensile test, and this is fine. All these things they will say. So this is incoming. While the raw material is coming, they will do the inspection, and then while manufacturing the process, right, they have to take some samples when the syringe is getting processed, and they will be just doing, maybe if it is an injection molding, the parameter setting, and then the injection molding, the output is coming, then they have to do some random sampling test of the devices or maybe of the components. And for that, a mechanical engineer will be taking that, and they will just do, okay, this is like kind of in line with the requirements. Okay, this is the size, the dimension is fine, the calibrations are fine, all these things they will be doing. And then final inspection. So once all these things are assembled, maybe if you see a syringe, there are 3 components you can see without needle. One is it will have a barrel, and it will have a plunger, and the plunger end will have some polymer bud. Okay, so these three things will be manufactured differently, but maybe finally we will be having an assembly, like line assembly. Once that is assembled, one person has to go and check whether really it is working as expected or not. So this is how we are sustaining the medical devices in the industry. So sustenance engineering is the key area, is very important for any legal manufacturer of medical devices to have a confidence and credibility, or to consistently maintain the product standards in the market. They should be having sustenance engineering concepts. So this is the three things, right? Mechanical engineers will be used for research and development, and or we will be used for new product development, or we will be used for sustenance engineering. Okay, so mechanical engineering in healthcare industry in research and development. So I was just saying research and development, new product development, and sustenance engineering. No? So the new product development and sustenance part I will club it together, but I will tell you how a research and development thing will happen. So if there is a project given to you, right, and the expectation is maybe like by 2019 end we have a huge outbreak, right? Corona. So Covidian is a company, and they initiated a process of having some research on the COVID-19 viruses. So what they did, they tried to understand the pattern of the viruses. They try to understand the pattern of how it will be spreading and how far it can like kind of travel, and how far it can sustain. All these things they did. Typically, we know like from one part of the global region it spreads across, but they did an analysis on all the parts of the globe, and to do an analysis, they required a technology, right? So how they can do the analysis, like maybe if it is a microscopical analysis, or if it is a petri dish analysis, or whatever it is, it involves a device. If it is a microscope, it is a device. So behind creation of that microscope, a mechanical engineer will be there, or maybe so many engineers will be there, but we will also be playing a major part. But if the new thing that is coming up is not at all into the historic history, it is a very new issue, new pathogenic condition, then we will be seeking for how we can improve the technology, right, to see or to understand the new pathogenic condition. So that is how a research will happen. Or knowledge-based development. So a knowledge-based development is maybe India will be having a limited knowledge, right? Maybe if you take European countries, or maybe China is having a different set of approaching a particular issue in the medical device world, then we will be getting the knowledge from that place, or maybe we will be seeing some writings, be seeing some theses, like the PhD people will be submitting. So all this knowledge-based development we will do. So we will research that, and we will try to bring that as a new device. And analysis and data-based development is, so whatever is there in the market, whatever is there in the current world of medical device engineering, we will analyze that, and they will try to improve, right? They will try to improve from the analysis point. Okay, this is what I have analyzed. This particular device is not working for 3 years. Maybe if it is a stent, right? The stent is working only for maybe 18 months it is working. So you have to have an analysis, like historically you have to analyze and come up with the data, and based on that you have to develop, okay, this stent is not working, I have to come up with a different stent model, right, to have a good life of that device as well as the patient. And new pathology of disease, that the example I gave for COVID-19. So when a new pathological disease or something is coming, then we will be going with a new way of thinking or putting the research into place. And enhance the support. So there is no issue at all. So there is no technology, there is we are not getting something knowledge, or the analysis is fine, or there is no new pathology comes, but still we will always try to improve from the place where we are standing now. So from this place where we are standing now, we will try to improve, right? So that is an enhanced support. So based on that also research and development can happen. So I'm not going in detail into research and development, and I would like to take you to like kind of sustenance engineering more. Maybe a new product development, I'll just give a heads up for maybe for a few minutes. Okay, so what is how a new product will get developed is we will have an idea. So the idea will be generated and they will screen. If you are coming up with an idea, they will screen or they will review the idea. And based on the screening, okay, the idea is fine. If they say you have to come up with a concept on how this idea can be done. And an idea can be achieved in so many different concepts. You can achieve the same idea in different concepts, right? So you can use different tools, different methods, all these things can be done. So you have to come up with a concept of how this idea can be done. Then you have to come up with a business strategic development, whether it is really needed for the business. You cannot just go and invest your time, energy, money and everything for something as just an idea I have got, I'm getting and I'll be just working on it now. So it should have a business impact or it should have a life impact. Something should be there. So a strategy will be happening based on the concept. It is really needed. It will really help someone, or if the company will get revenue out of it. All these things they will think. And then once that is done, then we will be going to the product development cycle. And once it is developed, we will be just going with the test marketing. So we'll just give it to the audience and we will see how it is working. And then we will go with the proper commercialization. We will say we are coming up with a new device and this device is having this many features and this is going to help everyone, all these things. And then we will introduce the device into the market. So this is the cycle of how a new product will be developed in an industry. Okay. So now we are into the sustenance engineering part, or maybe it is applicable for a new product development also. So these are all the major milestones, right? I'll just explain you with few examples, right? And I think when we are into a manufacturing world, manufacturing company, then this will be the major milestones for any of the medical device products. Okay, so we will be conceptualizing a product, then we will come up with a design plan. A design plan includes so many information. So it is not only maybe it is not just only a plan about just a theoretical thing. It should have some data to show that this is my plan. The design that I'm going to implement for this particular concept is having all these things. The plan should have how I'm going to document an input, how I'm going to document the output of the design, how a validation will be done, how a risk will be managed, and how a human factor verification will be done, and how I will maintain the files for that, and how I'm going to comply with the industrial regulatory and standardized standards. So all these things you have to plan, right? So in the plan you have to say everything what you're going to do for this particular concept. Then you will come up with a design input. Design input is nothing but, hey, I have a requirement, maybe.
So mic is muted, sir.
Am I audible now? So how long it is muted?
Sir, right now, sir.
Okay. Again, you can see the screen.
Yeah, sir, visible, sir.
Okay. So an input is nothing but a theoretical data. So what would be your input? So, boss, I have an issue like patients are coming and the patients are having blockage in their blood vessels, right? So what is your design input? You'll be just having an input how a device can be, or how the concept that you're creating, this will be going inside the blood vessel and clearing out all the blockages and it will come out. So it will have the physical requirement of the device. Maybe what is the dimensional feature and how far it should be, what is the length, what should be the material, and what sort of mechanism we will be applying to maybe introducing that into the human body. All these things will be your input. Just a data, just in theory. And design output is based on all these requirements, you will come up with the 3D model or maybe a 2D model in your CAD design. Okay, so someone is saying people are having more blockages into the blood vessel, and we have just roughly drafted some device design, and this should be properly properly outputted in a form of a design, in form of a drawing. So the design output will be a drawing. Okay, then you will be doing test method validation. All these things I will cover in the upcoming slides. Okay, so I'll just take you through one quick example of how you can just watch this video. You guys can hear the audio from that video, right?
Sir, audio is not available, sir, but you have to share that tab itself, sir. Share the tab. You enter a screen, you know, sir. Stop presenting and you have to share the tab.
Okay, start presenting.
Presenting a tab, sir. Window tab.
Okay, okay. So, but I think I have presented my tab only. Okay. This one, huh? You can hear this now?
So please play, sir. No, sir.
No?
So voice is not audible, sir.
Okay, you can just see, maybe I'll explain it, right? So this is a stent actually, right? So how the stent will be manufacturing, you can see. It is just a stent, and I'll tell you where the stent will go in real time. Okay, it is just a quick video. So this is a hub where this will be automatically, this is just an animation, right? So automatically we will be having a threader through that, right? This stent will be created, and this is the stent actually. What you're seeing here is the stent. You guys can hear me, please. Okay, so you're just going with the heat treatment process. Prabhuji, you can hear me, no?
Voice is audible, sir. Voice is audible, sir, but video,
that's fine. Yeah, it's okay. I'll just explain. So now, once the manufacturing is done, you're going with the heat treatment process, and you're making. So each and every step will involve a verification, right? It's just an animation, but every step you have to do a lab test, how the hardness and all these things and all. So once this is done, you will be sizing it, and this is a polishing mechanism that is happening. This will be very interesting if you see. Okay, so all these small kind of the fur and all these things will go out, because this is the stent that will be used inside the human body, like inside the blood vessels, right? So now the polishing is happening, and once the polishing is done, after polishing, this is before polishing with so many ribbon hardened item at the surface. This is after polishing. The surfaces will be very neat and clean to be used. Okay, this will be, if you see, it's very small. It will be like kind of 3 mm in diameter and 40 mm in length, but it will be very strong, kind of very stable. This is the cell size, right? Based on the design input, right? Based on the design input, this will be created. Now the stent is ready, and we are putting it over silicone material just to retain the shape of that. Okay, so the silicone membrane is not to degrade it. Okay, now it is done. So pretty much once it is done, we will be, and they are conform. So if you see conformity and flexibility, this is the testing they will do in the lab. They will be doing engineering analysis as well as they will be doing real-time lab testing, how far it is stable, how far it is like kind of flexible, and the tensile strength is this much, and this is the bonding failure point. So all these things they will test as like the SOM lab, no? So whatever we are having, maybe some different mechanism, but we will have the ultimate tensile machine, so to have some analysis over the tensility of it. Okay, so now the stent is ready. Okay. These are all kind of variant stents. The stents only is of numerous patterns, numerous types, different engineering persons, right? There are so many patents our mechanical engineers will file. Okay, this pattern is not fine. I'll be going with a new pattern of that knurling thing. So like kind of the braided thing. So they will file a patent, and if it is really a new pattern, then they will get a patent. And okay, this is done. Now the stent is ready. Okay, just an animation, just for your, don't try to understand more and more. Just understand like, okay, this is a stent. A stent will be looking like this, and we will place the stent here, airway stent. Like we will place the stent here. Through this device only, it will be entering human body. Okay, wow. Now. Now you see, there are so many vessels will be connecting to our heart, maybe arteries and auricles and ventricles. Okay, this is how a plague is nothing but a conjunction is happening. So this is the maybe whatever we are eating, no, the unwanted things like the urea thing or whatever the unwanted thing that is whatever we are eating, no, that will be added as a component, of inside your blood, and those unwanted things will subside, and it will like kind of okay, let me explain that. Okay, so these are all like kind of unwanted blockages, like your urea, whatever you're consuming, right? The unwanted things, the junk food, the junk food thing that the body doesn't require or it is not compatible with the body, then everything will get stained and it will stick to your blood vessels, which will be blocking the blood vessels, passage of your blood vessel. If the blood is not traveling to your heart, then it is a cardiac issue. Okay. So now our mechanism of stent, how it will work here. So you understand one thing: any implant operations will be happening under the supervision of a technician, and majorly a technician will be a mechanical engineer. Okay. Let us see how it is happening. Now what they are doing, this is our device, what we have designed. So now this is a balloon angioplasty. This is a mechanical engineer designed device. So through this balloon, you are trying to increase the width or the dia of the blood vessel so that your blood can pass without any issue. So you will not have any heart block. Okay, so this is one mechanism. And once after you clear this thing, no, once after you clear this, again there is a possibility, a major possibility that this will grow very quickly, or in some other places it will grow. That is a different thing. But our main purpose of the therapy is the patient is having blockage at this particular area, maybe 90% block, 85% block will be there in this particular area. That's why the blood is not traveling. Sometimes the blood will auto bypass through some other route and it will reach through some other veins. But sometimes it will not happen where the patients will require major attention. This we are calling it as first attack, second attack, and all, no, heart attacks. So if you just leave it as it is, there is a possibility that this will grow again. So what we are doing, we are now applying our, like, kind of putting our stent over here. This is like kind of known, it could be known by everyone, but just a general thing. I'll just relate to the scope of this presentation once after the video is done. Okay, so based on the patient's condition, right? So now you're just doing like kind of working on the stent. Give me a minute. Okay. You should have seen this. So one more thing I'll show you. This is another pattern or way of how it will work. This is a rotor thing. You guys can hear the audio?
No, sir.
Okay, fine. See, this is another one. This is another one way of like kind of another one medical device that invented by one of our mechanical engineers from Europe. So it is like kind of a rotor thing whenever they are having a chest pain, right? So now if you see, this is very not that much way that the blood vessels are having. These round things are like kind of your blood vessels, right? So now they're doing things through a rotor blade, right? As like a drilling machine, this will drill down your calcium deposit. Maybe the calcium deposits are like kind of very hard, as like kind of your bone. You cannot just drill it like that. And for the aged patients and all, are very underage patients and all, like this rotor blade should be used. So once the rotor is going in, it will create a space for the blood vessels to flow, and once that is done, stents will be applied. Okay. Now let us go back to our original presentation. Okay. So to do this sort of medical devices, what a mechanical engineer should do, right? And what would be our scope in the industry? I'll tell you. So this is a medical device technical documentation, which is released by MCE, authorized representatives from Europe. Okay. So they have released this requirements document on how a medical device should be manufactured based on EU. EU is European Union, right? In EU, like in Europe, these regulations should be followed. In India, we do have a CDSCO organization, which is a regulatory authority, and they will come and inspect your devices. Give me 1 minute. Sorry. Okay. So I'll go back to this particular MED document. So you guys can see the MED document, right? Which I'm showing that MC.
No, sir.
No. Okay. I have to re-present again. Could you see this now? The medical device technical documentation, I'm sharing a PDF.
Yes, sir.
Okay. So if it is a medical device, a mechanical engineer should have knowledge on how you have to technically document your medical device in a structured way, right? So this has been released by MCE, which is an authorized representative of medical devices from Europe, right? So this is the structure that we have to create. If I explain you the structure, maybe pretty much you can understand, okay, as a mechanical engineer, how I have, if I'm going into a medical device engineering world, what I have to do. You can easily understand that. It is very easy, and you will be getting training in the respective organizations. Okay, so the regulation is nothing but the government rule or EU. EU is European Union. So any devices you are manufacturing in Europe or you are supplying to Europe, maybe you are manufacturing in India or you are supplying to Europe, then that particular devices should follow this regulation. This is the regulation number, and these are all the upcoming specifications. Okay. So you have to describe the device in a technical way, and you have to say, okay, these are all the variant, maybe version 1, version 2 I do have, and what is the purpose of the device, right? It is just not a device. The device will do what efficient work, right, that you have to say. So these are all some sub-level information. And once that is done, you have to say my UDI. UDI is nothing but your barcode. You have to have a specific barcode for your device. And designation and classification, pretty much in Europe, they classify the device into 4 categories. One is class 1, class 2, AB, and class 3. Class 1 is nothing but your surgical gloves, the apron, you will use, everything is medical device only. Everything is manufactured, everything should be manufactured under the supervision of mechanical engineers who are all trained, and everything is considered as a medical device. Even though if it is a gloves, it is a medical device. Okay. So class 1 devices are like low risk devices, And class 2A are like kind of a devices which are all, the classification is based on the risk factor. Because if the gloves is not that much okay on, that is fine. But surgical gloves are class 2B, right? So normal gloves and surgical gloves are different. So because surgical gloves should be still more good in manufacturing thing. So class 1, class 2A, class 2B, and then class 3. Class 3 are the implants, whatever we are saying, no? The stent and all these things are class 3 devices. So you have to decide, a mechanical engineer pretty much sitting along with the medical officer and the manufacturing unit, they have to decide, okay, what is the classification of my device? And then confirm it, you have to confirm, okay, this is the device that I'm going to put into the market. And you have to describe, here is what, describe the principle of operation of the device and its mode of action. Sometimes it will have a small mechanism, sometimes it will have an electromechanical feature, sometimes it will be operated through a software, sometimes you will have a button, some segment display, all these things. No? So what principle of operation the device will be working? And you have to explain the principle of operation in a comprehensive way. Then you have to say the safety and clinical performances. So how far the device is safe to use. You cannot just introduce a device which are like kind of very unethical or unsafe. And the clinical performance is clinical. Whenever you see the term clinical, that means human. Clinical means human or any life, like any pets or other things. Pretty much in this document, whatever you're seeing clinical, it represents the humans. So how the device will be performing with the human body, right? So it is not like you're doing something for something else, right? We are creating a device, we are manufacturing a device for a patient who is eventually a human, right? So how the performance of the device would be with a human and how it is safe and how it will be performing good with a human. Then you have to say what is the raw materials you are going to use, what are the components you are going to use, what is the packaging material you are going to use, all these things you have to explain. Then you have to say these are all the information that I am giving as an integral part of my product. My product is having, if you see, my product is, if it is manufactured using human tissue, so some of the products we will use human tissue. If you are using human cell or human tissue or any origin from human, you have to get a separate certificate. Or if it is from animal origin, you have to get a different certificate. Or if it is having any sort of medicinal products. If you take a Band-Aid, right? A Band-Aid. So Band-Aid will have it is a medical device. A Band-Aid will have a top layer substance and it will have a medication inside and it will have a like kind of a label. You have to just put it on your injured place, then you have to just take it out and you have to stick it. So it has a medicinal product. It is a medicinal product. It is a device and it is having a medicinal product inside that, integrated to it. So you have to say, okay, this is the medicinal product. Medicinal product means a pharma product I am having in that. And what are the previous similar generations? Okay, if you are using an insulin pump or any ECG machine, any X-ray machine or any blood glucose monitor, is there any previous generations available or if this is similar to the existing generation that you have to say? Then labeling is a very critical part, guys. Like you have to give the label very appropriately and you have to give the instructions for use in a very detailed way and it should be accepted in all the languages. Especially in Europe, there are 26 languages across Europe. So you have to print your instructions for use in 26 languages. And here comes the whole matter of design and manufacturing information. You have to document whatever you are doing. You have to document in a very proper way about your design. What is the design process you are using? What are the phases that I have explained, initially, design input, design output, and all these things you have to explain. And you have to understand if you are outsourcing something, that also you have to say. And if it is comprehensively, you have to describe what is your manufacturing procedure you are going to use. And what is the where you are giving and what is the address of your manufacturing site. And how the process is getting validated. Maybe if it is, for example, coating, processing, injection molding, soldering, bonding, welding, like lyophilization or cleaning. So anything, if it is happening, cleaning is also a major part. It should have zero kind of virus-free, zero bacterial-free cleaning you have to do using isopropyl alcohol. You have to sanitize it, all these things are there. Then you have to say information, so how you are doing your controlling, like the information on the controlled condition. That means like what are the steps you are taking in your manufacturing process. And then the quality control. So how we are going to control the quality? Maybe one batch will have a good product and next batch will not have a good product. So how we are going to monitor that you have to say. And if you are outsourcing few products, right? If you are taking a syringe, maybe the barrel you are manufacturing, plunger you are manufacturing, but the rubber stud that you are not manufacturing, you are giving to a subcontractor. So if you are outsourcing that and you are just getting from him and you are assembling, then you have to say the process about the subcontractors. And GSPR is a major another requirement. You have to understand before manufacturing anything, you have to understand what is the general safety and performance requirement you have to consider. They will be asking what are the general, the government will be asking, or you have to give the document about the GSPR requirements. Okay. And then here comes the benefit risk analysis. Okay. So the benefit risk analysis is something like if you are coming up, some issue is there, and for that issue you are coming up with a solution, and you are saying that I am going to manufacture a product, medical device. If the medical device is not having any benefit, right, and the medical device is having more risk, the government will not approve your proposal. To put it in another way, you have to understand the benefit risk matrix by doing risk management. So this risk management should be followed by ISO 14971 standard. For example, we are using our syringe and needle to inject medication. Correct? So what is the risk of having is, if you inject a needle, obviously you will get a pain, right? If you're pricking your body with some sharp object, you will get pain. It is pain. The pain is a risk. And if you are taking it out, maybe some people will have irritation and skin related inflammation. They'll be allergic to the needle substance and all these things. So your needle should be compatible enough to be introduced into a human body. So the risk is the patient who is going to get the usage of the needle, they are going to suffer with the pain. And what is the benefit? The benefit is they will have an improved health, right? So if you see, compare this both benefit and risk, the benefit is higher in range, whereas the risk is residual. The risk is there. It is not like we are going to eliminate the risk, right? The risk is still there. We cannot eliminate, we cannot say this is a needle we are coming up with. If you inject, you will not get pain. There is no way we can say, or we can do, or we can come up with a product. We can manufacture a product. Every medical devices will have its own risk, but the risk should be within a threshold limit. It should be manageable, it should be recoverable, or it should have a proper standard saying that this risk is there, but when I compare my benefit, the benefit is more compared to the risk, so I'm okay to introduce this, or I'm okay to have this product into the market, then I'm manufacturing it. So this benefit risk analysis you have to do. For that you have to have a risk management plan. How you are going to manage your risk. Then you have to have a control measure. Then you have to report. You have to report all the control measures. I'll explain you with an ISO standard. Okay. Very quickly I will explain. So this is an international standard of medical devices where you have to manage your risk, or how you have to manage your risk. So this is a vast document, but I will just tell you through few important factors. Okay. 7. Okay. You should have a risk management plan. Okay, you have to write a plan on how I'm going to manage the risk of this particular device. Okay. So once you are planning that, you have to have some analysis done on the risk. You have to evaluate your risk, and you have to control your risk, and you have to see if the risk is residual or not. So how it will be done, I'll explain in one bit small thing, small example, or maybe going through this document I'll explain. You will have to identify and describe the medical device. So how a medical device, so what is the medical device that you are planning and how it will be impacting the patient. Maybe. What is the intended use you have to understand. And if it is having a reasonable foreseeable misuse, if the device can be misused by the patient or by the healthcare professional, then that is a risk. Okay? Maybe the intended use is something different. The IFU is saying something different, but the user is using it differently. It is a risk. Okay. And what are the characters related to the safety? Any character, physical character, chemical character, biological characters that are related to the safety, you have to document. And you have to understand what is the hazard, and if this hazard is having, what could be the hazard situation. And you have to estimate your risk in numbers. In numbers you have to play. When you are doing a risk management, you have to play with the numbers, and you have to estimate. That means you have to numerate your risk in values, in quantifiable, not qualifiable. Qualifiable just behavior, it will irritate, it will pain. Pain is a quality, correct? But how you will quantify that? That is where the mechanical engineer will play a role. So they have to convert that quality data into a quantity data, and you have to estimate this is the risk. Right? I'm just giving an example, like kind of giving an idea on how you have to do. You don't need to worry more. You will have good guidances in the industries. Then you will see if there is any already standard applicable, if there is any scientific evidences there to say that this device is okay, or if there is any field data performed to the patients, or what is the usability test report it is saying. Clinical evidence is nothing but your human trial evidence. And the investigation or anything if you have done on the particular device usage you have to do, or you have to get the expert opinion from the scholars or from the healthcare professionals, and external quality assessment you have to do. So all these things you have to do. Based on this you will estimate. Then you will evaluate, okay, this is the number. This is the number I'm having, maybe within 200 now, okay, the risk is okay. If it is significant, maybe more than 200, then the risk is more. You have to estimate with a number, and you will be evaluate, okay, these are all the numbers, maybe these are all the issues or the risks I'm evaluating the device is having. Then if that is the risk, what is your control on it? How you can control that particular risk? Maybe sometimes you can educate the patient to not to misuse. You can give instructions for use at a base level. But in the design itself, how you can control the risk? The concept itself, how you can control the risk? So that control you have to do. And once that is done, then you have to implement your control measure. So whatever the control you are documenting, that you have to implement in real time. And once it is implemented, you have to see if still there are any residual risk is there. Then you have to evaluate it again. Then once you see every risk is mitigated, as much as possible we have reduced the needle size as much as possible so that the pain will be less. Then after that you will do the benefit risk analysis. So if the benefit is more, the risk is somewhat acceptable, then the government will approve and you can go ahead with the manufacturing of the device. So risk arising from risk control measures you have to do, and completeness of risk control you have to document everything. So this is how you will evaluate it overall risk. Then you will review your risk then and there. It's not like one time I have done, it's done. No. It is a lifetime risk management. It's a lifetime process until the product is there in the market or until the product you are manufacturing. You have to do the review of the, you have to review the risk of the product. Okay. So this is how you have to do the risk management thing. So technical document I have explained. For example, if it is a product design phase, then you will understand the expectation is I have to supply, I have to deliver glucose to the patient. This is the expectation. Then you will say, okay, I need a solution bag, I need a transfer set with the thread, I need a Y port. So if you see the Y port, this is having much of mechanical engineering thing. It is not a T port, or it is not a Z port. It is a Y port. Why? One place you will have your solution, like the glucose will get delivered, and on place any other external medication they want to add it to the glucose, they will deliver. Why there is a Y port? Here if you see, if it is T port, here the turbulence flow will be more. The flow will not be laminar here. So they want to have a laminar flow here, like the part of the thing should go without having any hindrance to the medication that will be supplied. That is why they are going with the Y port. So everything, if you see, there will be a basic mechanical engineering concepts will be there. Right? Then you need a silicon tube. Yes, you need a drip chamber that it will drip drop by drop, and you need a roller clamp to adjust. Then you need a catheter to inject. Then you need a catheter and needle and everything you need. So if you are just saying, okay, I have to supply glucose to the patient, you have to think from the design phase what are all the things you need and how it should come. Okay, and then that is done. You have to come up with the requirement. If this is a solution bag, what should be the volume it should be capable of having, or what it should be transparent enough, it should be chemically inert. So many things you have to come up now. So all these physical requirements you have to come up with. Then you have to do tensile strength, flow rate test, laminar and turbulent analysis, engineering analysis in FEA, drop test. Right? This will be usually 1.2 meter height they will hang. If it if it is dropped down, maybe through mishandling, there is a risk. So what is the risk? Maybe the user may mishandle and drop it. That is a risk. If it is dropped from 1.2 meter height or an average human height, it should not get break. So you will say that I will do a drop test and I will make sure that it will not break. And burst test. While filling the saline or something, it should not burst. So what should be the stability that it should have? You have to come up with a requirement on, okay, this is the torque it should maintain, or this is the Newton it should handle, or this is the pressure it should handle, or this is the it should have. So these are the tolerance the design can have. So visually, if you see, it should be very transparent, very clear. If some solution is going, I should be able to see, and it should be white in color, or it should be yellow in color. So all the visual related thing, and functional demonstration. Something, if you roll, no, you cannot describe things. You have to roll and then you can check. So few things, if you have to tick a pen, if you just do like this, it should bring a sound. How you will evaluate? You have to functionally do that, and you have to hear the sound, then you can evaluate. Right? So the functional demonstration you have to do, and aging analysis you have to do, and usability test you have to do. So what is the aging analysis? I will explain. This roller should work for maybe 100 times, if you say, or else this bag should have 5 years of shelf life. Shelf life means it should have 5 years of shelf life, the solution bag. Okay. So will you wait for 5 years to check whether this bag is okay or it is getting deteriorated? It is not making any sense, correct? You cannot wait for 5 years to say, to understand this bag will be qualified. So that you have to do some aging test. Maybe technically you will be knowing, but just for your understanding, I will be saying that you no need to wait for 5 years, but for 5 years also we will keep the samples, but we will do some aging, accelerated aging, then we will test the sample. So, and accuracy and precision, right? So accuracy and precision is very, very, very key when it comes to the medical devices manufacturing part. If it is a rod, right, and how far it is precise, maybe the top is, for example, it should be 100 cross 20 mm. Maybe if it is a silicon tube, it should be 100 cross 20 mm. Then this is 20 here, maybe 25 here, 20 here, 25 here, 20 here. Then it is not precise. You have to understand this is not at all precise product. So the product should be first of all precise as per the requirement. You should have all the places 20 mm. Top 20, top middle, bottom middle, bottom. It should be 20 mm. And it should have 100 mm length. And another thing, if this 100 mm cross 20 mm will be going to, maybe this tube is going, this is a precise tube, 100 cross 20. This is going to a Y, maybe a Y port, and it should be compatible, it should be accurate in terms of, it should be accurately fit inside this precise product. Even though if it is precise, it should be accurately work on the function. If this is 10 mm and maybe this is 20 mm to say, just for an example, this cannot be 20 mm, but if this is 20 mm and where it is going, it is at 30 mm, the tolerance is more, then it is not an accurate product. The compatibility is not there. So you should have a precise product, and also you should have an accurate product to help with the purpose. So you have to do some testing, which is attribute test or variable test, where you will be analyzing your standard deviation, and you'll be doing your repeatability and reproducibility test using some Minitab or some analysis. or in some places you will be having some ANOVA table related exercises, some statistical analysis you have to do to validate this is the test method where I'm going to test my particular product. Okay, and the risk management already I have explained. And design verification is nothing but, what is the design verification is, you have the product now, you have to go and check with the input. Input is your dimension. For example, you have a CAD drawing, and for the CAD drawing, you are making a product. The CAD drawing and the product dimension should match. Then it is accurate. Okay. If the CAD drawing is saying something and your product is not saying something, then it is not accurate. So you have to do an output. What is the product, and maybe what is the requirement? This analysis you have to do, and you have to ensure all the requirements are satisfied and verified to pass. And in case of any deviation you have to work on the deviation, and you have to do some impact analysis based on equipment. If there is an issue in the equipment, or if there is an issue in the process, or an issue in the operator who is doing the manufacturing thing, or if there is any environmental factor it is affecting. That is why the verification is not passed. You have to understand, and you have to validate it. Finally, the intention is it should work as intended, right? So it is not like all the verification is done, but it is not working as intended. For example, yeah, the connection is done. I have placed the switch, and the bulb has been done. What is the validation? Once you switch it on, the bulb should glow. Correct? That is the ultimate intended use. If that is not happening, it is no use. So if the amps is passing correct, it is a bulb with the good quality, switch with good quality, it is connecting properly. So everything you are verifying. But ultimately, the verification why we are doing, it should pass the validation. Once you switch it on, the bulb should glow. So when you are putting it into the real-time experience, it should work as intended. So that is what it is validated. So you have to do the validation in lab. Then you have to do your clinical safety and performance using human trial you have to do. Then you have to see how it is working in the human. So these are all some basic components. You can see syringe, needle, catheter, thermometer. So these are all some, in a hospital if you go, these things will be there. And behind everything, every of these individual medical devices, there's a mechanical engineer involved. So I think that is what I do have. I think I'm right top on the clock for this 1 hour. I'm ready for any questions or something you have, any doubts, maybe you guys can ask me. I believe like maybe it's giving some idea about how a mechanical engineering person can like help in the medical device engineering world. Someone is saying something I couldn't hear. Maybe I'm not hearing, or
Participants have any doubt, you may ask.
maybe is there any question in the chat? Maybe someone can read. I can see if I can help by answering. Any questions, guys? Any understanding you? Okay. I think then it is fine. And you can reach out to Prabhu sir, and maybe he can help me connected in case of any questions, or maybe I can share some documents or any other stuff that you guys may need to have a better future. So what is the next thing, Prabhu sir?
So that's all, sir. All
Okay.
sessions are finished, is there?
Okay, so I can leave now.
Yeah, sir. Thank you, sir. Thank you very much, sir.
Yeah, I'm really happy the folks that who are joined, and I wish you all the very best for your career, and wish you all the best. Thank you.
Thank you, sir. Okay. Next will be the valedictory function. So I request our HOD, Department of Mechanical Engineering, Dr.G. Mahesh, for his continuous support. This program made a successful one. I will hand over the session to our HOD, Dr. G. Mahesh, sir.
Good evening to one and all present here. It's audible?
Sir,
Professor?
audible.
Yeah, okay.
Audible.
Good evening to one and
1
all
minute, sir.
present here.
So 1 minute, sir.
Yeah, okay.
Sir, I request all the participants to switch on your camera for valedictory function. Okay, so you can start, sir.
So good evening to one and all present here. So I think 1 week all of you enjoyed the sessions and learned about Industry 4.0 in smart manufacturing, robotics, automation, additive manufacturing, nanomaterials, automobile NVH using finite element analysis, AI in manufacturing, future of smart manufacturing, etc. So I think all of you enjoyed the session, right? Okay. So I hope all of you learned something new in the last 1 week. Right? So thank you all of you for that. Right. So first of all, I thank the AICT ATAL, so who granted this online FDP to JCTCET Coimbatore. So I thank you AICT ATAL. So then I thank our management, then Secretary Sir, so who motivated us to apply the ATAL online FDP. So I gratitude to our beloved principal, Dr. S. Manoharan sir. So he is motivated as in all the occasion. So I thank you, sir. So I thank the resource persons so who accept our invitation immediately with their busy schedule. So I thank Dr. N.M. Sivaraman, Assistant Professor Pondicherry, NIT Pondicherry. Thank you, sir. So Mr. Rajkumar Sengodian Kannayan, Project Manager, Danfoss, Denmark. Thank you, sir. Dr. S. Sendil Kumar, Professor, Anna Sahib Dan College, Madhya Pradesh. Thank you, sir. Mr. Babu Devendran, Director, Future CAE Technologies, United Kingdom. Thank you, sir. Dr. S. Suresh Vellayan, Professor, Savita School of Engineering, Savita University, Chennai. Thank you, sir. Mr. Rajendran Narayanasamy, Senior Specialist, Sacha Engineering, Fort, Chennai. Thank you, sir. Dr. R. Deepak Kumar, Assistant Professor, VIT Vellore. Thank you, sir. Dr. D. Dinakaran, Senior Technical Manager, R&D, HCL Technologies, Chennai. Thank you, sir. Dr. T.C. Ganesh, Professor, VIT Vellore. Thank you, sir. Dr. S. Karthik, Senior Consultant, Capgemini, Bangalore. Thank you, sir. Dr. M. Arulprakasajothi, Professor, KCG College of Engineering and Technology, Chennai. Thank you, sir. Mr. Ganesh Babu Palanisamy, Tech Lead Engineering, Ingersoll-Rand Technologies and Service Private Limited, Bangalore. Thank you, sir. Mr. Nirmalkumar Arputharaj, Senior Quality and Regulatory Engineer, Medtronic Engineering and Innovation Center, Hyderabad. Thank you, sir. So once again, I thank all the resource persons so who took the sessions very nice. Oh, thank you, sir. And I thank all the participants from various parts of the country who are all enjoyed in learning sessions. So thank you one and all who are all the participants. So thank you all. So I thank to all my colleagues who supported to organize this FDP to a grand success. So thank you all my colleagues. So I thank the co-coordinator Mr. Prabhu who is the backbone of this online 6-day FDP. So without Prabhu, this is not possible. So I thank very much and very much so Prabhu. Thank you, sir. Prabhu, sir.
Sir.
Thank you, sir. So I thank who are all support directly and indirectly to this online FDP to get success. So thank you, sir. So once again, I thank all of you. Thank you, and keep learning process. Right. So this is not a one-time process. So always we have to keep learning process, and future also we have to join once again. Oh, thank you very much. Thank you, sir.
Thank you, sir.
Thank you, sir. Prabhu, sir, you can take a snapshot for all these photos.
Taken, sir.
Yeah, okay. Thank you.
So participant, I will post the last session feedback and also the test link through your mail and also in official ATAL WhatsApp group. So you make it. So the timing will be 6 to 8. Within the time, all of you have to complete your test. After that, the link will disable. So thank you all for this 6-day online FTP. I thank all the participants and our HOD and our management and our principal, Dr. S. Manogaran sir, and our HOD G. Mahesh sir. Thank you all.
Thank you, sir. Thank you, sir.